Okay. Hey, Thomas. Hey, thanks for coming. Yeah, hey you. Uh, I'm Josh Lifton, co-founder of Crowd Supply. This is our second annual now Teardown event. Thank you all for being here. Yeah, for those of you who were here last year, thanks for coming back. Our goal this year is the same as last year. We all want to do it again, all right? So that includes the staff and volunteers, the attendees, the sponsors, like everyone involved. If they all walk away wanting to do this again, then we've won. So please help with that effort in any way you can. Yeah, so for those of you who are not here physically, the internet, we have internet streaming this year. There's live video streaming. There's also Gitter channels, so you can join the Gitter channels. I believe there's an update that was posted last night with those links. You can, if there's a social chat room on Gitter, and there's a quote-unquote official chat room where we will be sending out announcements as things come up. So check that out. We have a slew of sessions. I think we have about 50 sessions slated for the weekend, some of them doubling up. We have a bunch of talks. We have panels this year, which is new. We have workshops. Installations and demos are upstairs. In general, this room is for talks, and the Hammer Boardroom, which is as soon as you walk out this door, if you look up, you see some windows. That's the Hammer Boardroom. It's on the second floor. That's for talks as well, although today it's a workshop. Make Think Code, which is our partner in putting this on. So Make Think Code is a program here at PNCA. We are at the Pacific Northwest College of Art. Thank them very much for letting us use their beautiful space. Make Think Code, yep. Make Think Code, which is part of PNCA, has been working with us. They have a very cool space up there on the second floor. We'll be using it for labs and workshops up there, so you'll get to see that as well. And Nandini will have a few words to say about Make Think Code in a second. Some logistics. I know some of you are thirsty. There's water. Yeah. Now the trick is it's upstairs. There's a water bottle filling station, so like the kind you see in airports these days. So easy to fill this up in just a few seconds. It's upstairs past the commons and in the restroom cluster. Now, where are the restrooms? Another fine question. And I have answers. This map is in the program. It's in the last page of the program. It shows you what parts of this building we will be active in. So this is the Mediatheque. It's on the first floor. Right outside is the atrium. The second floor, not the mezzanine level, but you have to go up 2 flights essentially to get to the second floor, is where the commons are. In the commons, there's a bunch of demo tables already set up, installations, people showing off. We have sculpture, we have software-defined radio, we have art, paintings. Actually, the painting didn't make it, which I'll talk about in a second. And then on the 5th floor, we have one room for workshops. So you want to take the elevators or stairs, so near the main entrance, go all the way up. It's room 510. There are signs pointing to all these things. Okay. And on that map, it also clearly denotes the restrooms. So there's plenty of restrooms out there. If you have any questions about anything, whether it's directions or you need something from us or we need something from you, you can grab anyone in one of these color shirts that says Teardown. If you happen to be wearing this color shirt, I'm sorry. Or a yellow shirt. So same printing, but yellow are volunteers. So we have a bunch of volunteers. Thank you all, and a bunch of staff here to make this go smoothly. If you need anything at all, let us know. The security folks keeping us safe and keeping the building safe are doing their job, and they don't know much about this event. So if come to us first, unless it's an emergency, of course. We have a code of conduct. It's pretty straightforward. It's in the program on the first page there. Basically, be nice, don't harass anyone, and it'll be fine. If you do have any problems or you see some problems, let us know and we'll deal with it. There have been a few program changes. I'll announce them now. That's the beautiful thing about printed programs. They're wrong immediately. And that is, it was wrong even before it was printed, actually, in my case. I forgot my script that generated it all had a off by one error. And so Sophie's description and listing didn't get it into the printed program. Sophie Wong, and her title is it's the Wearable Tech Designing for the Human Body. It is now online, and you can read the full description there. And so I encourage you to look at the online version. The printed version is a good suggestion, but the online version is actually correct. So sorry about that, Sophie. We added some things as well. So the programmable air talk will have a demo now associated with it. It's upstairs. It's very cool. You should check out Squishy Robots by Amitabh. We lost two sessions, the hardware hacking with JavaScript and Esprino and the OLED dystopia installation. But we're adding stuff. We've already added stuff to replace that. So that's it for changes to the program. This year we brought in some. I've been working with all year some really interesting sponsors. Our platinum level sponsors this year are Microchip, Corvo, and Molex, and they're sponsoring. They're all the sponsors make this happen. With those three in particular, though, we were working with them not just during Teardown, but all year, and launching these design competitions around their particular component lines. So you'll see some projects actually launching. Some have already launched earlier this year as part of those competitions and challenges. You can check them out on crowdsupply.com, of course, and some of them will be here showing stuff off. So that's a really interesting thing that's new for us at CrowdSupply and is going really well. Tonight, so today is kind of a half day. We have 4 talks, we have 4 workshops, and then we're going to break at 5:30, kind of reconvene here, and we'll give you more instructions about what we're doing tonight. But in summary, we're going to Autodesk, which is just across the river. I'll talk about how to get there tonight in a few hours. And they've been kind enough to host us and sponsor Teardown again. We're also adding this year a puzzle hunt, which will take place in the after hours of every day. Obviously, you're not required to do it, but it's pretty fun, I think, or I hope so. And that will take you around town a bit. So we'll start at Autodesk and kind of meander around as you can't figure stuff out. Yes. So, Nani, do you want to give a few words about Make Think Code? Come on up. Any questions so far? Cool. Yeah, one question.
What's the Wi-Fi password?
Aha. It's in the program. Look at this first page. I believe it's Take It Apart. Yeah. And next year will probably be Take It Apart also. So just keep it saved. Yeah.
Hello, everybody. First, thank you for joining us. We're really excited to be part of Teardown and to do this again. I'm Nandini. I am one of many PNCA Make Think Code people in the room. I think we've all kind of done there are lots of you who have kind of interacted with us in some way or the other, but there's some of you who haven't, so maybe I'll mention a couple things. Make Think Code is sort of an interdisciplinary art technology lab at PNCA. We have a beautiful space upstairs, but we also do workshops and intensives and hackathons. We design stuff with hardware, stuff with coding, stuff with data. Everything we do is open to the community, so all of the people involved are not just purely PNCA students or faculty. We we did a civic data unconference. We do stuff with sort of other groups in the city, both sort of tech groups, design groups. So it's a place to come and play across sort of disciplines and sectors. And that's the goal, that we wanted a place where interesting people have ways to find each other, to work on projects together. And all of these ways are just ways to gather people. So if there's something you'd like to do there, if you have projects or an event or a workshop you'd like to teach, or a workshop you'd think someone ought to teach because it should be there, come and talk to me, wander around. We'll be around all week. There are many people from PNCA and Make Think Code here. And thank you to all of you, because you're helping sort of all of this is part of what we do. So I sort of think of it as building this community of Make Think Code. So I'm excited to have you join.
And I can vouch for Make Think Code being really fun. I taught a workshop there earlier, and I've taken part in a bunch of their stuff. It's a blast. Okay, a few other things. The workshops, today's workshops are just you go up there, first come, first served. There's four workshops in parallel. One of them is going to be about the conference badge, which you should all have. Now, you're going to need this badge and the associated pin with it that's on the lanyard. You don't have to keep the pin on the lanyard, but you're going to need both of these things to get into the after-hours events. So keep them with you. There's security at Autodesk. They're going to actually have a non-disclosure for you to sign, and you have to sign in. If you're not comfortable with that, you can't go to Autodesk. Sorry. But it's very easy. And then tomorrow we're going to Control H, which is our local hackerspace in Portland. I'll explain how to get there. We're going to take public transit. There's a Max line that runs right there. And again, you'll need the badge to get in there and the pin to get in there. At the end of every day, we're going to have a raffle. We have all sorts of stuff, and we don't want it anymore. So you guys get it. Really, though, we just cleaned out our basement, and I'm amazed at what we found down there. We get prototypes from people we didn't even know were sending them, and ideas that never really matured, and but some just leftover stock. So it's hit and miss. It's mystery box. And to enter the raffle, all you have to do is in the Gitter channel, put in your unique ID that's on your badge. Now the badge has an NFC chip on it. And I'm going to let the creator of the badge talk about this. But first, I want to thank Royal Circuits for actually making this happen. Right? We got these fabbed at Royal Circuits. They did a great job and super quick. So thanks to them. Yep.
Thanks.
And Greg, where's Greg? Is going to talk for a few minutes about. He's giving a workshop later, right after the main talk. After this, but right now he's going to give a few words.
Hey, thanks. So, like you said, there's an NFC chip on the card. You can pull down the ST25 Android app if you want to get access to that. My workshop is going to go through that, show you how to do things like put your contact information on there so you can share your vCard with a tap. And I'm also going to go over a couple advanced capabilities. There's a quick connector on there. And so we'll show you how to connect it to a microcontroller and what that enables. And if anybody complains that there's not a shitty add-on connector on the badge, come to the workshop. I've got quick shitty adapters. Thank you.
Okay. Yes, you'll need your badge, and so it's worth learning how to use. Now. The talks are 25 minutes and 50 minutes. So instead of expecting people to teleport to the next talk, we give you 5 minutes this time, or 10 minutes if it's a longer talk. So we are going to be pretty strict about keeping things on schedule. And to that end, I'm going to get off stage and welcome our Kickoff Keynote from Helen Lee. You ready?
Give me a second. I need to set up a couple of things. Oh, no, I'm good. Actually, can you put that in there?
Yes.
Thank already dropped that laptop before in my life, and I don't want to do it again. All right. No, it doesn't matter. Cool. Huh? Oh, yeah, go for it.
Sorry, forgot one thing. For the workshops beyond today, so there's no signing up today. You'll actually sign up right outside the door. For the other workshops, we're going to open registration right at the beginning of the day in the morning. And you sign up, and then when the workshop happens that day, we'll check you off. So please don't just sign up for all of them just so you grab a spot. That's rude. Unless you're going to go to all of them, which is cool.
Oh, wow. You can see some of my code. Da, da, da. All right. I think that might work. All right. We just set a timer. Ah, fuck. Awesome. Cool. Right. Can you all hear me? Awesome. I'm a bit of a wanderer, so please excuse me if I'm like dabbling around outside of this. All right, so today I am going to talk to you. Oh, first of all, hello, my name's Helen. Today I'm going to talk to you about how hacking and making has influenced music technology. We're going to go back in time and look at some weird sound art from the 1940s and the birth of electronic music. And then we're going to fast forward right to the present day and talk about some of the cool stuff that's coming out in music technology, weird sounding and cool sounding, and sometimes both, from London and Berlin. I'm currently based, more or less, in Berlin, so I do lots of music tech stuff there. I have brought, because apparently I never learn, I have brought some live demos. Which is a terrible idea, but we're going to see if they work. I made one of them in my hotel yesterday, and I think it's quite cute, but it does break a lot. So you're just going to have to forgive me. I do Twitter, so do follow me. I put loads of my makes up there. I'm less on Insta. I kind of suck at Insta, but if you're on Insta, add me. And there is my GitHub, which is largely full of very silly things. And I'll... wow, I think that just broke, never mind. I will talk to you a bit more about some of the stuff on my GitHub later. All right, so I guess I'd probably better tell you who on earth I am and why this lass has been asked here to talk about music technology. So I do probably 3 strands of things. First of all, I design products. I also write stuff. You're probably most familiar with Hackaday, so I'm a writer for Hackaday. In fact, I am covering Teardown for Hackaday, so if you have interesting projects, please bring them to me. so I can do my deadlines. And I also make a lot of signed art and a lot of music using signed art. Now, art is a very loaded term, isn't it? Really, it's everybody. When you say art, everybody feels like they have to have an opinion on it, but really, it's just silly stuff that I enjoy doing to improve my technique and explore different possibilities. I'll talk a bit more about that later, but I thought I'd show you. Haha, yes. This is one of the products I designed. Most recently, it's sold on Adafruit, and P. Maroney manufactured it, which is like British Adafruit, essentially. That's my hand. I should have said I'm also a hand model. Very proud of that. I modeled that. I was lying on the floor of this manufacturing room, and they made me put it. And I've got really wonky fingers, so Photoshop nail varnish onto me, and they were like, "Bend your fingers so you can't see how wonky they are." I was like, "All right," lying on the floor. It's not very glamorous being a model. Anyway, so yeah, that's my hand. I developed this. It's a gesture sensing instrument that is supposed to get children to learn to code. So they sew it, they wire it, they code it, and then they make chiptune-based instruments, so square waves, essentially. You can hack this. It's a $33 kit that's based on a $5,000 piece of equipment. I should mention, actually, I developed this for Imogen Heap, who's an artist and technologist, and she developed a very expensive MIDI controller, essentially, that uses gesture, flex sensing, and like a 9DOF IMU to kind of create electronic music on stage. Ariana Grande took a bunch of them on her last tour, so they have been used professionally, and I thought I'd like to create something that was very, very cheap and that you could hack into making something very musical. I mean, I've actually been quite surprised by how many musicians use this. I will show you a stupid thing I made with it later on. But so that's an example of a product I've made. This is a still from one of my books. I have written a number of books, but this was the first one in my own name that came out at Christmas this year, published by McGraw-Hill. It's called The Crafty Kid's Guide to DIY Electronics. And I do a lot of writing for education, I guess, because that's how you get paid. You know, nobody pays you to write arty nonsense. And then this is an example of one of the sound art things that I do. So I really like materials. One of the reasons why I really enjoy craft-based electronics is because you get to play with some really interesting different materials, from embroidered circuitry to different types of materials to like flexible PCBs, which hopefully we should get some of that coming this weekend. But this is a circuit sculpture. I was inspired by everybody's probably seen Mohit's work on Twitter. And Jiri as well. It makes these amazing, beautiful, intricate pieces of art that are also functioning circuitry. And I thought, I really want to do that. But I went along to this music technology hack with the idea of making this beautiful, intricate circuit sculpture. And I got there and I was like, well, actually, I want to make something big and wobbly out of some cool materials. So I made, this is actually, that's not life-size. It's considerably smaller than that. I've made a tiny one. This is one of the tiny ones I made. It fits on a breadboard. I'll have it out later. I'll play it later as well. But this is a bass, and we'll hear it in a bit. So that's about the size of a medium-sized dog, small to medium. But I've got one that's about the size of a chihuahua here as well, which is kind of cute. So I make lots of different instruments. My favorite technologies to use are capacitive touch and gesture control, just because I think they're really expressive and you can do some really cool things with them. All right, so that's me. Here we go. Let's talk about music tech hacking. This is a very pretentious quote, isn't it? Love it. John Cage, very famous for doing his compositions, very strange things, including 4 minutes and 33 seconds of silence with a full orchestra. But John Cage was actually a hardware engineer as well. He made really cool instruments. And the point I wanted to make, really, in this bit is that music technology comes from weirdness. So stuff that has been something that is... words. Okay, so Stravinsky, Debussy, Strauss, back in their time, they were considered to be weirdos and were booed off the stage and did these kind of compositions that really confused modern day people. And when we're going to, even like the violin, like in the 1500s, wasn't the violin. So the things that we think of as established music technologies are constantly changing. So it's really interesting to look back through time and think about things that we take for granted that were revolutionary and weird sounding and usually just played in a basement to people who were nodding their heads but secretly having a bad time, which is like a large amount of bars that I go to. So here we go. This is a tape recorder, and this used to be really very modern technology. Back in the 1920s, I think it was first developed, but it became popularized in the 1940s after the war era. And this is magnetic tape, I should say, sorry. And this was the basis. Tinkerers and hackers and engineers used this machine to create a whole new form of sound. So if you think about a normal, hang on, how am I going to do this with one hand? All right, so if you think about a normal sound, this is a glass here. We all know what a glass sounds like when you tap it. But something that's interesting about almost all naturally occurring sounds is something like this starts really quickly and then drops off slowly, okay? But when you record it on something like this, you're then able to take a pair of scissors or a scalpel, cut it, flip it around, and that sound is then in reverse. So it's got in music you'd call it decay, like how long the note takes to drop off. So it goes long, it starts quickly and it goes on long. So if you flip it around, you've then got this sound that doesn't occur in nature. And that's what musique concrète, we've got lots of really interesting people who worked in that. And you can go on YouTube and listen to lots of their really, really bad music. You can just really go down a hole. I mean, I think the reason I started talking about musique concrète rather than avant-garde music a lot earlier is that it's recorded from the 1940s. We actually have like a surviving recorder. I mean, if I'm talking about Stravinsky, of course there were other weirder people mucking around with violins in that time, but they are consigned to the dustbin of history, survivor bias and all that. But yeah, so Schaeffer and Stockhausen were two of the pioneers in musique concrète, and you can listen to some of that on the internet. But you can also, if you listen to music from the 60s, anything like by The Who, Floyd, the Beatles, hear their influence. So they made weird music. Right? What they actually did was develop a technique. They developed tools. They developed a way of working. And actually Schaeffer worked on the Beatles' Revolver album. So if you think about, there's a classic song, I can't embed YouTube in Keynote, otherwise I would have played it. There's Tomorrow Never Knows by the Beatles, At the beginning of that, you'll hear the whom kind of sounds, and that is classic musique concrète. It's backwards samples, essentially. But that was originally created by hackers making weird things. So I wanted to say that. So basically, their technique was to go around with a recorder. This is a modern day version. It's called field recording. Just costs about $100. So Zoom H1N. You go around, you collect sounds, and then you can mess with them. In the old days, it would be just having a microphone on one of these. You go and record sounds, someone banging on a railing or sounds of trains or whatever. That's called field recording. And then you'd literally, with a scalpel and some sticky tape, slice them up, speed them up, re-record them, and then stick them together. And that's how you made music. That is analog, right? This is before the computers did this. You used to, until actually not that long ago, you used to actually physically cut up these samples. Work. So this loop transposition, which is like speeding it up to make it a different sound. And then literal sticky tape and scalpels. That's how they made a lot of music back then. So musique concrète, hackers making terrible music, but actually had a huge influence on modern day music and sampling. We're not going to follow the music route. Oh no, that's the Revolver. I was going to probably tell about that. This lass. Who knows who this is? Nobody knows who she is. She's amazing. This is Daphne Orem, okay? Daphne Orem is probably the godmother of all electronic music. She was the first person to mix live electronic music and an orchestra, an analog orchestra, like like human beings with their instruments. She was the first person to make a track out of pure sine wave that she recorded from her oscilloscope as well. She was born in the 1920s, and when you're born in the 1920s, you don't get to do interesting jobs if you are a woman, particularly not if you're working class. She was trained in physics and music, and then basically to get a job at the BBC, and they took her on as like someone who lines up tapes, essentially. So she'd take the reels and she'd line them up and put like magnetic, classical music back to back. But she went on a training tour to Paris, and she met a bunch of the people from Musique Concrète, and they blew her mind. She went back to the BBC and she was like, look, this is amazing, this new technology. I know she knew about physics, she knew about electronics, and she had a classical background in music as well. And she was like, this has huge potential. And they were like, don't be ridiculous, go back to queuing your obviously. But she then, instead of giving up, she finished her day job queuing up music tapes, and then she off, steal the keys to the audio studio, steal a whole bunch of other things, slice things up, and work all night until she, 8 years later, managed to convince somebody to give her a platform for the strange music that she was creating. And it was just I think it was a sci-fi incidental music. And they were like, yeah, all right, Daphne, here you go, we'll give you this. But they loved it, the audience loved it, and she started getting more and more. And eventually, she was given the opportunity to open her own studio, a studio that is still iconic today. It's called the BBC Radiophonic Workshop. And she opened that in 1958 because she was becoming very, very popular. However, sadly, a year later, she left. She said that she was being pushed out of meetings. They wanted her. She said they wanted her ideas, they wanted her work, but they didn't want her. So she left. And she left to start up her own workshop, and she made the weirdest synthesizer of all time. It's called the Ronix Machine. It's on display in the Science Museum in London. And it's basically these huge loops of clear tape, and you, with a watercolor brush, you draw on lines, and then something scans it and then creates notes out of the watercolor and painting. It was very strange. It was one of the early synthesizers, pure electronic stuff. So Daphne Orem, yes, she made the BBC Radiophonic Workshop and then was kind of kicked out. But we're not going to follow her weird. But she does have a book that's just been reissued called The Individual Note of Music, Sound and Electronics. So if you're interested in the physics of music and electronics, early electronics in music technology, would recommend you get that. I think they only printed like 3,000 for a Kickstarter. So, so the Radiophonic Workshop, I think that's most famous for is. Do we know who this is? No. Okay, this is Delia Derbyshire. Do we know who Delia Derbyshire is? No. Wow. Okay, Delia Derbyshire is an electronic musician, an experimental musician. She's most for doing the Doctor Who theme tune. Those woo woo woo. Those are all handmade, stuck together with sticky tape, cut up with scalpels. Yeah, she's fantastic. I mean, actually, if you want to hear some of her music, there's loads of her music and Daphne Orem's music actually on YouTube as well. Really peculiar. But there's a great track that she wrote called Zooey Zooey O-O, which sounds like it's straight out of like a banging club track, and she wrote it in the 50s. It's really cool. So yeah, she's really interesting. But this whole era was really exciting because there was new technology to play with, a decent amount of budget, and there was new applications for technology as well. So basically, and the radiophonic work was essentially one of the first places in the whole world to be able to fully experiment with sound within an institution, which was kind of exciting. And this, I think, is a very hacky quote. I quite like that. So there was no such thing as an expert in that field. So they were just making stuff up as they went along. And it didn't really matter if things broke, and it didn't really matter if things were a bit hacky. And I think that's kind of a nice sentiment for making art with technology. Anyway, all right, so that's a whistle-stop tour of one piece of equipment, the tape recorder, and how it influenced. And the influence is still known today. Like, it's huge. Like, the whole area of Foley artists, which is like sound engineering, and lots of different modern techniques all came from that original weird art collective in Paris in the 1940s. So I think it's important to recognize the roots of major technology innovations are sometimes a little peculiar. All right, so let's think about it. So that was cool, but what about now? So today we're having a huge boom in music technology. There's a number of reasons for this. One is electronics, as you know, are more and more accessible, and lots of artists are getting their hands on them, and there's a huge community. So I'm going to talk about that a little bit later. And I'll talk about it now, whatever. So, so something that I find really important, both for hacking and for my music, is thinking about the community in which it's placed. You know, it's tempting to think about artists and technologists and engineers as being this lone genius who doesn't really, who's there casting away, forging a path on his own, this whole kind of like idea of like Steve Jobs, the genius, the man, the polo neck, but actually it's community that's the most important thing. Even Picasso, who is, again, like someone who you see as this like dude who just knows how to be a genius just on his own. Like Picasso was surrounded by peers, surrounded by community that inspired him. There's a reason why he lived in the places that he lived. If it hadn't been for Braque and Matisse, Picasso would not have been Picasso. It's really important to place music technology or any kind of technology, particularly in communities like us, within the context in which they come. Like, I mean, I wouldn't know half of the stuff that I know without being directly able to access community and ask people how they do things. It's really important. Why did I start talking about that? Oh yes, because you can do lots of cool things nowadays. So I'm going to tell you about some of the cool technologies that are really exciting me that you can have a go on. But first of all, no, I'm going to skip past that one. Oh, no, I'm not. Oh, that's cool. Okay, so I wanted to make the point that most makerspaces, decent-sized makerspaces, do have music hacking communities, and it's a really great way of learning about this. And you can often find, so this is Machine's Room. I was a hacker in residence there. It says in London, sorry. Doesn't exist anymore, obviously. They put the rent up 3 times. But this thing in the front here, this is also a musical instrument. It actually comes from this guy who's it's a guy called Tim Yates made this, and it's very simple. It's some sticks, some poles, whatever, wood, and a giant saw blade, and you just hit it with a hammer, and it's very simple, but it's one of the most effective pieces of it's just really satisfying. So you don't have to fill everything with electronics. But yeah, so hackerspaces, you can go there. Festivals, this is me and my friend Phoenix. There's actually really shit instrument that I made. It didn't work. The reason she's on stage is she had to reboot me every 20 seconds. Yeah. So this is EMF. Is a big festival in the UK. So festivals, like technology festivals, I don't know what the equivalent in the US is, but in Europe we have something called CCC, which is like Chaos Computing Club, and every 4 years they have a summer camp, and every year they have a congress, and it's basically a bit like Maker Faire if everybody was suspicious of you and wearing black, and there were no children. So, I mean, that's what Congress is. Camp, I don't know, I'm going to my first one in August. But this is EMF, which was a spin-off from it. And it's like a Glastonbury for nerds. So instead of going to see a band, you might go and see Algo Rave. And instead of going to see stand-up comedy, you might see me being rebooted on stage. So yeah, events like that are really cool. And then this is one of the key things for modern community and music tech is YouTube. Everyone's on YouTube. Has anyone seen this? Yeah, okay, right. None of you have heard of Delia Derbyshire, but everyone's heard of Sam. So this is Sam, who runs Lookman New Computer. And this is horrific. It is a church organ that he's hacked into a Furby organ. So it's a chorus of tuned Furbies, and it is honestly as bad as it sounds. I fully recommend you look at that up on YouTube if you want to ruin your day. Yeah, so YouTube's great for that. Oh yes, this is what I wanted to say. Here we go. So these are the cool things you can do at home. I'm in a hacker space. You're all here because you make stuff, pretty much, or you want to make stuff, or you're just really lost. I want to talk to you about the cool hardware that exists at the moment, the cool software, and also a couple of different applications. So hardware instruments is usually like some kind of MIDI or OSC device using various, you might use this. You can use pretty much any microcontroller or single board computer to make an instrument. They do things kind of differently. I would say my favorite at the moment is this one, this bad boy. This is a baler, and it's a cape to go on a beagle bone, and it makes use of the beagle bone's ability to be like super, super fast, to have incredible latency. Now, latency is just a term for how long it takes from doing something to the thing being, the output being done. And analog to analog on a baler is 0.1 milliseconds. So you can actually create a percussive instrument with this microcontroller. I mean, an Arduino, you can make an awful sounding theremin. Of course you can. But I mean, and the Pi, no shade, but it's like 9 milliseconds of latency, which means you can't use it for something that you pluck or something that you hit. That's just, you can hear that. It's unacceptable. But the baler is great. And the cool thing about the baler as well, which I really like, is you can drag on different programs, which takes me on to software, and I'll come back to baler in a hot second. So this is Pure Data. Okay, Pure Data is an open source piece of software, which is, it's used to make noises, nice ones. So when you go, a lot of people have made an instrument, right? But often they will sound really bad. We'll have if I hear another instrument that just uses like sine wave, I think I will cry because I don't want to hear that tinny nonsense. So you can then take the next step. Once you've made the actual controller, you can start making things that sound nice. And it's kind of important, when you're making a musical instrument to also make music. That might be controversial. So this is a patch that I created. And basically, what you can do with a baler is just drag your noise onto the baler and then use it as an embedded thing rather than having to connect it to your laptops. So I'll take you through that in a minute. I'll do a demo because everybody wants that. Okay, and the other thing I wanted to say, software. So you've got Super Collider, you can use processing, that's great. Max MSP and Pure Data are kind of the same thing. They're written by the same dude. I've forgotten his name, but basically, I don't think he was too happy that Max MSP the price was jacked up, so he quit and created his own open source version, which is pretty identical. It's just got an ugly GUI. So would recommend Pure Data. To trigger cool things. I'll show you what that does in a hot minute. And then if you wanted to have a go on making some music without hardware, why would you? But if you do, I know people like coding, there's something really cool that you should check out called Sonic Pi. And it is essentially, has anyone heard of Algorave? Okay, so Algorave is like one person. Okay, cool. So Algorave is kind of what it sounds like. It's algorithmic, rave, right? It's what nerds do to party in certain parts of London. It's live coding music, essentially. And you project the code that you're creating at the same time as you're playing it. And it sounds banging, actually. There's a whole club scene. It's niche, to be fair. It is niche. It is niche. But it's really cool. And if you want to have a crack at that, there's a really awesome free, I think it's even browser-based, thing called Sonic Pi. Sonic as in, Sonic, and Pi as in Raspberry. Although it doesn't use Python. I think Raspberry Pi just paid for it to be developed. But now it's like completely free and open. And it's super easy to have a go on. So if you want to, feel like a rock star DJ, you can do that pretty easily. It's also great for teaching people to code who normally wouldn't care about code. So would recommend Sonic Pi, Algo Rave, having it large with code. All right, so, yes, here's some projects that I've done recently. I wanted to show you some cool. I've got enough time to do this. Let me put this in my pocket. Oh yes, here we go. So, some projects. Let me see if I can make some things work because, live demos, they definitely always work. This is my friend Andrew. He is a composer and a sound designer, and this is a project that he's worked on before. So him, me, and Drew Festini, we worked on the Sonic circuit sculpture creatures, which I'll probably just play them and you can see what I mean. Let me see if it works. Does it work? No. Oh no, maybe. Is it going to turn on? Oh yeah, cool. 2 modulation. Wah, 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 wah. So that's something we made in an afternoon, and we've got one. I've got a mini one of that here with me. So if anybody wants to play with it, you can. That's just a Pure Data patch on a capacitive touch board by Baylor. They're about to bring them out, actually. I think they've got 26 cap touch pins on the board. It's great. I'm very excited. And then here's another one that I made as well. If it works. It does. Okay, cool. It's a messy one. So that one's a polyphonic creature. It sounds a bit like a harp, and it's made of steel wire. The first one's made out of brass rods, by the way. And yeah, so those are 2 creatures I made in collaboration with Andrew and Drew. And what's this? Oh, this is my... why have I put this here? Oh, yeah. All right, this is a robot unicorn I made after I did like a 4-month job writing curriculum on the most boring robot of all time. It basically just followed lines and had a distance sensor, and I was like, if I have to spend another minute writing curriculum for a line following robot, I'm going to cry. So I set out to make the cheapest, most stupid robot of all time. And it's extremely unreliable. It's powered by 2 360-degree servos, which, as everybody who's used a servo knows, no 2 are the same. So some of them will go off in like weird loops. It's also, there's no H bridge. It's very cheap and very simple. Anyway, people loved them, so I made a herd of them and did them with gesture control. And then this girl called Rena made me a leather version. She's a leather artist. I have got this. What's this got to do with music? Okay, so so she made me this. This is my evil leather glove, made for summoning a robot army of unicorns. Yeah, I know I'm a ridiculous human being. But then I met this woman, Martine. Martine's literal job is, so she's known as the Moon Bounce Girl, and she records using a trusty Zoom recorder. She records instruments, and then she works with a group of astronomers with a satellite, with a satellite dish in the Netherlands, and she bounces the recorded samples off of the moon and then records what comes back. So I took a bunch of her samples of a cello being played and made it into a thing that works, hopefully, or maybe it won't. But I'll show you how it's supposed to work in the end. So let's get out of this. We don't want that anymore. I'm going to show you what's behind. Right. So all I'm doing here is I decided I wanted to see if I could make a. I mentioned the $5,000 MIDI controller that Imogen and so on made before, and I wanted to see if I could make a really cheap piece of equipment interface with my computer and interface with professional music software. So I'm using two of these in this hack. This is a microbit. It's a children's microcontroller that costs $10. It's basically indestructible, and there's millions of them. I mean, it's very popular in Europe. I think like the BBC gave away 1 million to children, every child of a certain age in the UK. So all I'm doing here is, let's see if that works. Could be, could not be. Yeah, okay, cool. So what I have here is I have a bridge. This is something called Hairless MIDI. It's a free piece of software. And this is just sending x-axis accelerometer data to another one of these cheap things, which is converting it then to MIDI signals, so 0 through 127, and then sending that data into my computer just via serial. And then this is a little bridge here, so it's going out into this, and let's see if I can make it work. I sometimes have to restart it, but let's give it a go, eh? Oh no. Right, see if that works. No. I don't have my glasses on either, which is probably an error. Oh no, that should work. Why is that not working? Oh. I know, I have to quit it and start it again. It's okay, don't worry, this always happens. It's the joys of open source software, isn't it? Audio on. There we go. Did I not click on that? I did a bad job. Where is it? No. Oh well, anyway, you can't hear it. But it sounds really cool. You just have to believe me. I don't know why it's not opening it up. Well, whatever. Okay, well, it makes cool cello sounds, okay? And it also makes use of a GitHub library that I've recently put up there, which is just machine noises. Oh, crap. So if you are interested in hearing what a field recording sounds like, on my GitHub there is something just called machine sounds. So I go around and record cool sounding machines from makerspaces. And if you wanted to submit a cool sounding machine from your makerspace, that would be awesome. And sorry that didn't work. Live demos. It's okay, it's a hacker conference, nobody cares. Oh, and this is the last thing I wanted to talk about. This is a project I'm currently working on with my next door neighbor, Johannes, who some of you may know from his FPGA board, the Doppler machine. Some of you may know from Dada machines, which is essentially a MIDI out a robotic drum machine. So the cool thing about the glove when my Pure Data patch works, which it wasn't, is that it takes analog data and then makes it into a MIDI signal. But this is the other way around, which is why I wanted to show it to you. Essentially, you draw a MIDI shape on it. I'll show you what I mean when I say a MIDI shape. So this, you can see here, you just draw something on. Okay, so you want this to hit there. And then you assign each of those. I'm not going to plug it in right now, but you assign each of those lines of notes to a different solenoid. A solenoid is just a motor that it goes in and out, right? It just goes bang, bang. And then you can create your own drum machine based around solenoids. So you're just drawing your MIDI. And this works on GarageBand and so on as well. It's just that I happen to have it in Ableton open here. So you can create like very intricate drum machines and percussive instruments that take MIDI in. So that was kind of 2 examples of cool MIDI products. And I think I've got to stop talking in a minute. I've lost my phone. Oh, it's in my pocket. Yeah, I do have to stop talking in a minute. But yeah, so basically this exists. It's a prototype of a tiny, it's like a, let me unplug it and I'll show you. It's this big. So this is the controller that allows you to take MIDI files and turn them into your own percussive instruments. This will be on, if me and Johannes get our shit together, it will be on Kickstarter later this year. I've got a working prototype with me. So if anybody wants to make a drum machine or a percussive instrument, I'm just going to be hanging around. So if you want to learn how to do it, I'm just going to be hanging out. I also have this with me. This is a tiny version. Look at it, so teeny weeny. It's a tiny, tiny version of a circuit sculpture creature. It's kind of delicate, and I need to calibrate the threshold for the cap touch because it keeps breaking, but it's here, you can play it. It doesn't matter if it gets broken. So if you want to have a poke, I mean, normally I would do them in a box because they'd be for display, but this one I made for y'all, and I know you don't care about boxes, so I've just banged it in a breadboard and left the wires showing so you can see actually how it's created. And this is the same for both of the instruments in the videos that I showed you earlier. So here we go. So I'll talk to you a little bit about it. So you can code it to do whatever you want with whatever software. But this is it's got 2 modulations. It's got like a delay, so it's quite short, and then it's got essentially a tremolo. No, it's just reset itself. Okay, well of course it did. Yeah, so it's got 2 different modulation settings and an octave of bass notes. But it does overheat a lot. So if anybody wants to help me figure out why it keeps crashing, help gratefully received. It's like part of what I'd like to do this week. This weekend is have a go on it. Oh, there's also going to be another instrument arriving, hopefully later today, but I don't know, which will be a Flex PCB prototype. So I'm quite excited by the possibilities of Flex PCBs. So I've made, with Drew, I've made a couple of different cap touch sensors, essentially, which we're going to hook up to an NPR 121, which is a cap touch board, and see how Flex works, because I think it would be really cool to have like properly moldable, wearable musical instruments, right? So this one's going to be I think I'm going to do like a necklace, but I don't know. I thought it would be cool to do like a vocoder necklace. What do you think? I think that sounds cool. But like, it doesn't really matter. But when we've made that, we're gonna chuck it up online on GitHub for anybody to have a look at. Speaking of, what is your GitHub, Helen? Is that okay? I've only got 6 repositories, and I'm a kind of crappy coder, so please be kind. But I've got the full instructions for Robot Unicorn. I've got my repository of machine sounds, which I do welcome people putting new weird sounds on that repository. I've got all the stuff for the cap touch creatures, including the Pure Data patches. You can just use those. If you want to make your own, just go on ahead and do it. It's pretty simple. What else have I got up there? Robot Unicorn, I already said that. Other things. Oh, and I'm doing a haptic homing device as well. That's going into a can-can dress, but that's nothing to do with music technology. But that's up there as well. So I put all my project files up on the internet, so you should check those out if you like. And that is my time. I think I've got time for a couple of questions. If anybody had any questions about Furby organs or capacitive touch or gesture sensing stuff or what it's like to go on tour with Imogen Heap, you can ask me. I think I've got to be off at like 15:15. Is that right? 20 past. All right, cool. So I've got 10 minutes of questions. So okay, how do we do this? I'm trying to figure that out. Oh, okay.
I suggest you.
Yeah, do I?
Call on people and then repeat the question into the microphone. Yeah.
Okay, yeah, cool. Why didn't you do that?
Okay, quick question about the gesture sensing. I was wondering if you played around with like edge machine learning for the gesture sensing, or is it like hard-coded?
So I haven't played around with machine learning, but I know somebody who has. There's a woman called Hadil Ayoub who's a professor at Goldsmiths University, and she does a lot of gesture sensing, machine learning stuff. I have done, actually that's an interesting piece of software to use. I have done a little bit of dabbling in kind of, what do you call, I don't know the proper term for it, like taught machine learning. Rather than, it's not like particularly smart, you're just telling it what to do in certain circumstances. But there's a great piece of open source software called Wekinator, Wekinator, which was developed by Rebecca Feebrink at Goldsmiths as well, actually. They do a lot of machine learning stuff at Goldsmiths. And it's a tool for, it's like an entry-level tool for machine learning, specifically designed for artists and hackers to be able to have a go at machine learning. And then it's got really good integration with other existing tools. So, for example, Pure Data is one of the tools that can be outputted to, or processing if you're a visual person, or LED matrices, matrices, sorry, et cetera, et cetera. So for machine learning, definitely check out Wekinator. It's free. It's pretty simple. I mean, the documentation's reasonable as well, because it's come out of university. But yeah, no, I haven't. I am pretty excited about what Baylor are going to do with. So BeagleBone have got a new board called it's like an AI board. Is that out yet? Oh, you're up from BeagleBone. Hi. Is BeagleBone's AI thing now available? Okay, cool. Okay, and
right now I think it's gonna ship in September as the current plan.
Yeah, but Baylor have already got one, right?
Bella does have one.
Exactly. So Baylor, every time BeagleBone release a new board, Baylor create a new hat or cape, as they call it, which is very much more dramatic than a hat, isn't it? I like it. It's a cape for the BeagleBone, and so Baylor aren't like a big company or anything. They're actually based out of a PhD research unit in London called the Augmented Instruments Laboratory. It's a very cool place. But they make these cool capes for BeagleBone, and I'm really excited to see what they come up with for this new BeagleBone AI. So I'm going to wait until they've done something with it. But I've made Club Mate bottles sing and so on using Wekinator, which was fun. But yeah, nothing huge. So anything else? Anyone else want to ask me a thing? Or shall I, just go and get coffee like everybody else? All right. What?
I have a microphone here.
Okay.
Do you have any specific recommendations for designing hardware that's designed to be durable for performance?
Ooh, yes, I do. So I often get brought in to teach creativity to engineers, but recently I got the opportunity to teach technology to musicians. I did a master's, I taught and wrote a master's module on sound creation to musicians, electronics to musicians. And as this is a convoluted way of coming to your question. But basically, something that really interested me is normally when I see engineers make instruments, they make them very much components first. And the musicians who had no experience, like I had to show them how to make their first circuit. Like they were like, "Oh my God, the LED lit up!" I was like, "Yes." Yeah, so they were like literally no knowledge of coding, no knowledge of electronics. Like literally copper tape circuit time it was. But by the end of it, they'd made these amazing musical instruments. And it's because instead of thinking about the technology first, they started thinking about the interactive experience that they wanted to create, and then were like, can I do this? And sometimes they'd be like, no, don't be ridiculous. And sometimes I'd be like, yeah, you can do that within the week that you have. So the range of instruments that were created by the musicians was very, very different to the kinds of instruments that I would normally see coming out of an engineering school, for example. So I do actually lecture on electronics and play at a product design-focused school in London from time to time. And I do tend to see, even though that they'll create their own PCBs and their code is really good and well annotated and so on, but I'm like, oh yeah, great, amazing, another theremin, cool, like. But the musicians who had almost no knowledge actually came up with some incredible things. So when you're talking about, design's really interesting. So of course you've got to design for durability, but actually designing for playability and designing for joy and designing for beauty are also just as important. I think it's very easy to kind of forget the purpose of the instrument in the design of it. But I think the thing, if you're doing a wearable instrument, my top tip would be to do strain relief and use silicone wire in terms of practical. I don't know why everybody just doesn't use silicone wire all the time. I guess it's more expensive, but it's like the bomb. It doesn't melt with your soldering iron. It's usually much higher quality. It feels really nice against your skin. And I mean, like, why don't people? Loads of engineers, like, what is silicone wire? I'm like, it's the best. It's literally the best. So silicone wire, doing strain relief, so kind of double rolls of holes in your PCB essentially. That's really important. I would say it's really difficult to calibrate. So this thing that always kind of breaks, the capacitive touch base creature worked really well in my apartment because I set the threshold in my apartment, right? You leave and you've suddenly got like very different levels with different numbers of people, different kinds of machines. So it's you do have to adjust the threshold quite often. And in terms of, what kind of, your durability issues, for the, make it removable. So I'm actually having this whole question with so I'm about to do a 2-month residency to create a kind of installation grade one of these sonic creatures, and I'm having the same kind of conversations with myself, like how on earth do I make like an art gallery level one of these when it breaks all the time, and the answer is not clear, but the answer is definitely, you have to have the PCB and the other thing. So basically, the thing I've broken quite a few of these and had to create them, and that's because transporting them, the joints stress. So I've sheared a whole bunch of through holes here. So I guess strain relief. Like whether it's hard scale PC, like hard PCBs or soft PCBs or embroidered anything, strain relief is the most important thing. It's usually wiring that's fucked up, right? Like it's never code; it's always wires. Is it? I think that's all my time. No.
One more question.
Okay,
Any
cool.
other
One
questions?
more question, if there is one.
And you're gonna have this stuff to show off during the demo?
Yeah. No, I'll bring all my stuff around. Someone can even have one of the circuit sculpture creatures.
Hello. You mentioned working with Imogen Heap on her music and her performances. Are there other kind of larger musicians that are using music and technology together to create new forms of music and art? Yes. There's lots of amazing musicians doing lots of interesting things with technologies. I'd say that Imogen's one of the more well-known ones because of this whole, because of the gloves.
the gloves have been in the press quite a lot, and they've just been through another whole round of work. But I mean, I tend to look more at the creators of the instruments themselves, just because that's the world in which I live. If you're interested in kind of the kind of avant-garde, kind of cutting edge, kind of music hardware type stuff, I would 100% recommend that you go to a festival. It's kind of a conference, but it's a conference called Superbooth. And that's held every year in Berlin, and it's like half performance, half largely hardware nerds who've made strange instruments out of things, and also the big players as well, like Shaw and Sennheiser and Korg and Moog and all that. So that's a really good place to go and check out. Yeah, it's really strange. It's great. Okay, Superbooth, yay!
Okay, let's give Helen a hand. Thank you very much.
You're very welcome.
Okay. Coming up next, yeah, it's kind of on. We have a snack break. For those of you doing workshops, they start at 3:30. There's 4 workshops starting at 3:30. There's the quick NFC prom workshop led by Greg, which I talked about just before this talk. So learn how to use your badge and read and write to the NFC ROM on there. There is a workshop about the hardware side of radio, right? So the antennas and give you an RF primer by Molex, by Matt from Molex, and he'll kind of explain kind of the amazing things that they're doing, getting antennas into consumer electronics or just into weird places you wouldn't have thought. So kind of advanced manufacturing techniques for custom antennas. At the same time, we have, if you're on the software side of things with radio, want to learn more about that, the Lime Microsystems team that's responsible for the Lime SDR, Lime SDR Mini, et cetera, they're here. They have demos upstairs also, but they're giving 2 workshops, one at 3:30 today and one tomorrow morning, I think starting at 10. It's the same workshop both times, so if you missed this session, you can go to that one. And then finally, if you've never actually soldered anything, which a lot of people haven't because they have keyboards in front of them all day, you can take a Learn to Solder workshop where you'll walk away with something you soldered yourself that works. It's a metronome. I've played with it. It's pretty neat. That will be by Brewster in the MTC lab where we're going to be doing all the soldering for the weekend. So that is that. Yeah, there's snack outside, and then we'll reconvene for talks in here. The next talk in here is by Alvaro Prieto, Learning Electronics and Software the Rainy Way. If you saw his talk about cheese making last year, you'll know what to expect. Yeah, you don't want to miss it. Okay, thanks.
I don't know anything about. Oh yeah, it's working. Is it working? Yeah. I heard myself a little bit. There will be no time for questions. Guaranteed. Yeah. Yeah. Oh, my friend made it for me. I don't know. Exactly like this. Yeah, yeah, yeah. Just flipped. Well, and this is the first time it's been all in one piece. Like, oh, funny. This is totally like that's really cool. Fake, yeah. Yeah, I sent a picture to a friend, and she just, I don't know if they're doing graphics stuff. Graphic stuff, yeah.
Hi, everybody. Hi. Alvaro's speaking up next with Learning Electronics and Software the Rainy Way.
Oh, can you hear me all right? Okay. I can hear myself, but I don't know. That happens normally. All right. So, yeah, this talk is... last year, my talk was Learning Electronics and Software the cheesy way, so I thought I'd augment on that. Yeah, so the rainy way, question mark. So this is about the two-year journey of making a weather station and kind of the lessons I learned along the way. It all started when I don't know how I found this website, but the Switch Dock Labs has this whole weather station project. And I saw it and it looked pretty cool. And then I looked inside of it and it's kind of a mess of things, right? It's got like Raspberry Pis, it's got all these cables and different individual modules for everything. And I thought to myself, oh, I'm an engineer. I could do this better, right? I could like make everything all, put it together in one thing. So I started and I bought their kit just for the top part. And you can see this in my lab at home. And just gonna explain it really quick. You have an anemometer, wind speed sensor, then you have wind direction, then you have a rain gauge there, and temperature, humidity, that kind of stuff. This came with its own controller that already was working and it had Wi-Fi and whatnot. But I wanted to, improve it. Oh, here was supposed to explain how this works. So this is a rain gauge. Actually, it's a tipping bucket rain gauge. So it fills up and then it tips. Boop, like that. And then every time it counts, it clicks. The wind speed, every time it turns, it sends a pulse. The wind direction is different resistance depending on the position. So I started and I made these kind of integrated boards, as you can see here. And it's using an NRF52, just Bluetooth. And it has these RJ11 or 14 connectors for the wind speed and direction. And from the start, I started having issues. So as you can see here, my footprint was incorrect. So I had to do some cutting around and fixing things. So again, lesson of always is check your footprints like 3 times at least. Yeah, so I started like this. It worked with Bluetooth, and I didn't do anything with it. I just lost interest and forgot about it until this year, I guess. Or no, yeah, December last year. So I set myself new rules. I'm just going to get something working no matter what. I don't care if it's using everything off the shelf, if it's totally like the original one I made. I just wanted it to work at first. And my biggest issue is premature optimization. It happens a lot. I start optimizing everything, try to make it as low power as possible, as small as possible, and then I just don't do it. So I started with the ST micronucleo boards. It's kind of a, I don't want to say an Arduino on steroids, but there's different microcontrollers. It's just a development board. And I started using the ARM embed software, which is kind of a, also Arduino on steroids. C++ libraries, they had a web compiler, and tons of libraries to kind of pull from. So then I made a breakout board for it. I was like, all right, I already have this working. I'm going to make this breakout board. It's going to use an XB radio, which is standard, like off-the-shelf radio. It's not cheap, but it works. And then I'm using off-the-shelf pressure sensor, off-the-shelf temperature sensor, all that stuff. So yeah, here's your pressure sensor. First mistake I made this board, and eventually it's going to run out of battery, but I didn't have a way to measure how much power it's using. So I had to cut some traces, Over here, another mistake I made is the XB, when it's just idling, it's using like tens of milliamps, which is way too much for a battery-powered device. Luckily, it has a sleep mode that'll put it down into the hundreds of microamps, and I just forgot to connect that pin, because there's a pin that tells you if it's or not the one you use, and then I have to use that. I started out with this ginormous box. This is a 12-volt lead-acid battery. I'm using my bike stand to hold this up outside. It's got a GPS, because why not? It might run away. And just off-the-shelf 12-volt to 5-volt regulator, and this waterproof box, and really high-tech cardboard mounting in the back. So I did this. Oh, you'll see down here, I have a waterproof box. How do I get cables in and out? So cable glands. I never heard of these before. Oh yeah, I'm an electrical engineer, firmware engineer. I know nothing about mechanical engineering, so this is also me learning mechanical things. So cable glands, never heard of them. They're really neat. I got a million pack off of Amazon. It's just these things. So there's a little gasket in there. You put your cables through, you screw it down, and it kind of locks, or it just makes a seal around your cable. So it's super cool. Drilling holes in these ABS plastic cases with when you have like a half-inch hole you need to drill, not good with just a regular drill bit. It just, bad things happen. So watching YouTube videos, I found out about these step drill bits. And they're used for kind of a machine, or folded extra, not aluminum, just like folded metal stuff, but they work great on plastic, and it just kind of drills a little bit at a time, and you already have the measurements on the side, so it's pretty great. Another really cool tool I found was the automatic center punch. People use these to break glasses in cars, but it's also useful for marking down where you want to drill a hole. So you just kind of punch down on it. It's got a spring. Just push it, and then it just makes a little tiny dimple, and then you can align your drill bit on there. All right, so I have this gigantic box, this gigantic solar panel, and the little weather station. It's still, there was no sun in December in San Mateo, California, because I'm next to a hill, so I still had to charge the battery every week or two myself, but it worked. The temperature humidity sensor has to be outside, because if it's inside the box, it's kind of not the right environment. You want to measure outside. So I made another high-tech Tupperware container rain shield. And you can see in the backyard, I have this PVC stand, just a bunch of folded pipes and whatnot. So Pvc Pipe Cutter, another tool that I didn't know existed until not that long ago. I used to use like a little saw to cut PVC pipe, and it sucks. This thing just ratchets. You close it, open and close it, and it just cuts right through the pipe. Fantastic. Another cool thing, just Google waterproof connectors, whatever. I needed a way to connect the solar panel in a waterproof fashion, because it's going to be raining outside. But then I still had the problem of, how do I connect this waterproof connector to the solar panel, because I have to strip the cable and then solder them together. And then you can do, it'll probably survive, but then I found out about these things, these solder sleeves. And it's heat shrink tubing, but in the middle it has solder, low melting point lead, and then it has glue on both sides. So you put the two cables. It's NASA approved, by the way, like NASA standards. But here's a better picture. You put the two wires, half stripped, and then you just heat gun, and it melts the lead, makes a connection, and makes it waterproof because of the glue on the sides. So it's pretty sweet. All right, so here's just a quick image of how it was working. The weather station was transmitting over XB to a Raspberry Pi, like that one over there, with an XB radio, and saving it all in a SQLite database, just using a Python script. So Python script's getting the data. Oh yeah, I'm also software stuff. Getting Python data and saving it to a database. And then I can SSH in from my computer over Wi-Fi, Raspberry Pi, and that's it. So here you go, here's a picture of what that kind of looked like. So this was the first version of the breakout board, so I made a new one. This one had a built-in GPS, because why not? I also added the pressure sensor instead of a breakout board, built it in there. I added before it was two different like phone jacks. So I found one that was 2-in-1. Oh no, what happened? The footprint's backwards. Again, the phone cable would go one way and then upside down on this one. It seemed like it was going to work, but it didn't, and so I had to do that. So just a picture comparing the two. You have your microcontroller board at the bottom, and then the breakout board to the top. So here's a new version. Sometimes you have to work inside. It kind of fits in my living room. It works. What else do I have here? All right, so we had just saving it into a database is not that exciting. So I figured I should learn how to make a little website that plots all this data for me. And I hate the cloud, so all this is local. My Raspberry Pi is in my home network, and I can connect to it from phone or from my laptop. And then I use all these technologies, Python, SQLite, Balma is some CSS framework, whatever. Plotly lets me make plots, and Flask is a Python web server, and I like them. So let me see if this works. Yay! So you can see here, if you go to this website, you have, this particular one. You have your temperature, humidity, pressure, all that stuff. Solar panel is not connected. We had some issues while shipping. But you can also go look at plots. So here you can tell this room is actually colder than outside. Anyway, you have these plots. When I move it, the tipping bucket tips and thinks it's raining. But yeah, so now I'm able to plot this data, which is much more useful than not plotting the data, of course. All right, so I had that microcontroller development board. I decided, let me integrate it all in one. So this new board has a really huge capacitor because I used a reference design from SparkFun, from Adafruit. A solar charger. So you have a solar panel, it goes to a LiPo battery or lithium ion, and that's that thing in the middle there. And I am now using an STM32 microcontroller without embed. I decided to switch over to use Apache Minute, which is an open source little RTOS, a real-time operating system that has Bluetooth support, even though I'm not using Bluetooth. It also has a fan controller. That little one part there is a DC to DC converter from like 3 volts to 5 because I was driving a fan. I thought I was going to have to move air around. I was wrong. I didn't care about the accuracy, let's just say. Problem here, I misconnected it. My schematic was wrong, basically. I didn't pay attention to what I plugged in what. So that was bad. Another thing here, this was a fun bug. I had an external GPS connector because I was like, I don't really need it, but just in case. And I thought I was being clever. I used every pin that I could in the microcontroller, and one of the pins happens to be the bootloader pin. And you can set it to just be a GPIO. But it was floating. So every time the microcontroller turned on, it would sometimes go into the bootloader, sometimes not, and I didn't know about this. And it gave me a lot of fun debugging. I had other issues, should have checked my footprints again. That that box was huge, so I tried to make it a little bit smaller. So I got a smaller box, and I found this YouTube channel called Modest Maker, and this guy makes external measurement things for some county and some state, I forgot. But he has a lot of great tutorials. So again, I used my high-tech plastic or cardboard to mount my circuit board, and you can see it there now. Exciting stuff. Oh yeah, cable gland. Make sure you put your cables through both pieces before you before you put your cables through. Otherwise, you have to take it off. Temperature humidity sensor. I didn't want it to get like soaked, so I made this very high-tech again PVC pipe with a little plastic hat. You can see here the size difference between the original box and this one. And again, it's outside my backyard, mounted with some cables. All right, so this is version 1.0. Then I made another one. It's a little bit smaller. I added this MOSFET to basically turn off the wind direction and other sensors, because the wind direction is just a resistor. So it's always just eating up power, and I'm only measuring once a minute. That's the point. So this MOSFET just gates the power and lets me only measure when I want to. Some fun surface mount stencils are fantastic. A little oven. I'm just flying through these because I wait. All right, so here's the board again. Oh, new lesson. Measure, like everyone says, measure twice, do it once or whatever. I measured like 3 times and I still did it wrong. I drilled the hole just the right length from the edge. It was just the wrong edge. I should have. Yeah, so you can see how that's for the solar panel. I just on the wrong side. Since I already had the hole at the bottom, that kind of determined which side was down. And I can't have, I don't know if, well, anyway, if the cable is too short for the solar panel, so if it would open, it wouldn't let me open the door, basically. Again, I upgraded from cardboard to plastic. This, I think, is from a strawberries container or box or something. Started mounting it again. Yeah, here we go. So you can tell if the solar panel cable was on the wrong side, it wouldn't let me open the box. The cable gland again. The solar panel cable was too thin, so I made it thicker with heat shrink tubing, and now it seals. Here it is again, outside, having fun. It rains. It survived. It never died because of water. I was pretty proud of myself. Here we go. And version 3 or 1.2, whatever. So here's a newer version. It has a bootloader button now, so I can boot into the serial bootloader in case something crashes. I was also able to use bootloading over the XB over wireless, which was fun. And I moved the solar panel connector just so it was better. Should have planned things out. I also explored with light, just environmental light sensing, because it'd be cool to see, maybe I can detect if clouds are going over or something. I don't know. But this has to be outside, and it's going to get wet, so I need some sort of protection around it. Never done conformal coating, so I said, why not? Ordered some silicone conformal coating, and I conformally coated the thing. And it works great. It's been outside for months. It's gotten rained on. The sun's been hitting it, and it's been fantastic. And this particular one, apparently you can even solder through it, which I don't know how that works, but it's pretty cool. All right, so I have a mostly working system, and then I traveled to Mexico, where my family lives. All this was a big scheme of getting my dad a birthday present, because he's a huge nerd, and he likes measuring things. So I took a clone of my weather station to Mexico, and we put it together. We wanted to make sure that bugs didn't get in there, because any sort of hole anywhere, bugs just live in it. Again, using household parts to water things. These cable protectors are fantastic because the sun just eats everything away, especially close to the equator. If you leave anything in the sun, it just gets destroyed. So these plastic bits, I don't know what they're called. I should have written that down. Do great protection stuff. Here's my dad installing it in his rooftop. These are not the solar panels for the weather station, but so here you can see it. It's over there. It's on top of the house, and it's been running great. So anyway, I flew back, and I kept working on my version of it, I guess. It was working, but I always like making things better, so why not keep going at it? You can see that huge capacitor again. Don't need it. I can use the little capacitor, or I thought I could, and it's yes, I can. I modified this board, and I changed the microcontroller to back to an RF52, which is what I started with, which is Bluetooth. Pointing that out, you'll notice that now I have two radios, this was just a risk mitigation. I didn't know if I was going to have it working now. So I have Bluetooth and then the XB. And I did get it working, luckily. The reason I switched to Bluetooth was everyone has Bluetooth devices everywhere, so it's going to work. And Bluetooth 5, BLE5 now has a long range. They use a different coding. They call it the LE coding or whatever. And it lets you do much longer range at lower data rates, but like hundreds of meters, which is good enough for me. And then I don't need this whole module. In order to speak that, the Raspberry Pi doesn't have the new Bluetooth chip, so I made a little USB stick, which is over there. And of course, I flipped the power and ground on the USB cable or connector. Don't do that. But again, I want it to get even smaller, and now my circuit board doesn't even. And here you can see the scale of the newest one and the older two. This time, I actually printed out my circuit boards to make sure everything fit. And now I'm using two different boards, one with the radio and one without. This time I was going to use an SMA connector on the outside of the case because the antenna before was inside. And I found this really neat waterproof SMA connector. Then on the inside, I have this, it's called MMCX connector to SMA adapter. Oh no, they're both the same gender. Okay, I can fix that. But now this looks ridiculous. It's just so I found another thing that's it's called no ring, and that's gonna hopefully be good enough. And here I am practicing how it's gonna fit. Oh yay, it fits. I used the KiCad SVG import. It's fantastic. So here's the new version of it. Now I just have the charger IC and then some of the sensors, and then I have a radio board. And I have the MMCX connector, but this is dual-sided surface mount. How do I do that? Just stencil, solder, and then flip it around, lift it up, another stencil. This is not an easy way of doing things, but I just wanted to see if I could. And it worked. So here's the latest evolution of this. TAC Connect. This is a great thing to program boards. It's just like pogo pins. That's great when you're doing single programming. But if you want to just leave it there to develop, there's this bottom thing that you use to hold it. Well, that didn't fit. I should have thought about that. Here's the smaller solar panel, because this thing uses like 100 microamps now, so it doesn't really need much. I'm using a joule scope to measure the current, and super useful. Making a new box, measure, whole bunch. All right. Oh yeah, this is great. So this is so tight that you can't really push things through. Like, you have to have the board outside to be able to connect everything, and these things don't fit. So I had to cut them to put them through, and then I learned all about crimping, and it's not that bad. This is a $10 TrendNet or whatever crimper, but then it worked. And then I put it in. Everything has to happen in order. If I have to remove the antenna connector to do this, that. Anyway, this is what it looks like, and that's what's here, and it's working. And without solar panel, it'll probably last a month. With a solar panel, forever. All right, so this is the way it was set up. So I wanted to access this from somewhere else as well as home. So I set up some server on DigitalOcean. Oh, no. So this was to manage my dad's one. My dad has a Raspberry Pi at home, and I want to be able to manage it. So I set up a server that one would connect to over SSH. So there's this thing called auto SSH. It just SSHs into my server, and then I can connect to my server and reverse connect to the Raspberry Pis. But this was not super reliable. So I found out about WireGuard, which is this really cool, lightweight VPN thing. And I'm going to do another live demo really quick. And now here, you can see from anywhere, this you can access on your phone. Let's see how the weather's in Mexico. And we can look at some plots. And for example, I can see how the temperature is over a week, over a month. And this is, my DAC can still access it locally, and then my server just talks to his over a private VPN. So it's not even, there's no single point of failure, I guess. Here are some more of the technologies I used, and that's it. I finished. Sorry. Yeah, this is all open hardware, of course, open source. The GitHub is not super well documented, but it's there. Oh, I never explained Chak. Chak is the Mayan god of rain and thunder. It's like the Mexican Thor, if you will. So that's what inspired me to call the project. I'm going to be around all weekend if you have questions, because we won't have time for questions. So just talk to me if you want or not. Yeah. Thank you.
Test.
Ah, got it. Okay. We should probably just keep that.
So yeah, I was. No, no, it still feels new. Right? Like I'm always finding something else to do, and like something I want to get into that I never would have experienced while I was back in Indiana. So, you native out here? Or?
Well, not exactly. I grew up in Idaho.
Okay. Boise or?
Yeah, Moscow.
Okay.
North Idaho. It's about 6 or 7 hours drive from here.
nice. Like Idaho was one of the places that really got me interested in coming out here. So as I was, yeah. So when I was working in the fab, I was working with a company that was making tools for me, and that was out of Boise. It was SPC, Santa Clara Plastics, and then they moved. I think when they moved out to Boise, they became JST. They did wet hoods, etch tools, chemical processing. No, they do like huge $1 million tools.
$1 million tools?
Yeah.
So this was actually muted up there, and I just
Okay. So this one's working. I'm not used to using a mic, so I was going to use my slide flippers. Too many hands are busy. Right, then I'm holding this.
Oh, right.
I need one hand to point at stuff.
Right. So you're standing here.
Yeah. Yeah, I'll probably be less mobile than I normally am. Should I wait for you to start?
Wait for me.
Okay.
Okay. Have a seat. Great. So there's one schedule change.
Kicking me off at the last minute?
No, you're on still. Don't worry. But we do have a few changes. We're going to have a fireside chat. After this talk, we're having a fireside chat with Joe Grand, hosted by Will Caruana. Unfortunately, Zach couldn't make it due to a last-minute emergency. He might come back later, but we have Joe and Will. But first, we have Brad from Corvo, who's just up the street in Hillsboro. Although Corvo, I was about to say you're everywhere, but that's your tagline. Yeah, right. So Corvo is a platinum sponsor. We're fortunate enough to have Brad here to talk about their QA process and their huge operation and kind of the interesting insights that we can learn and kind of spectate into their process. So Brad, take it away.
All right.
Thanks.
Thank you. So my name is Brad Silvers. I'm a Director of Customer Quality for Corvo. What that means is when our customers have issues, that comes back through my team. So we're in charge of keeping them happy and not just taking them out to dinner and carrying their bags when we're traveling. It's a whole lot of investigating issues with them, explaining to them issues that go wrong, and making sure our parts are high quality so they don't have problems. So a little bit about Corvo. We do a whole lot of RF, so we're really at the center of it all. That includes everything from, we have parts in satellites, we have parts in base stations, we have parts in just about every phone. Probably everybody here has a Corvo part in their pocket that you didn't know about. So we, last year, $3.1 billion, and that's pretty amazing considering it comes in tiny little pieces. Some of those parts in the cell phones may only be a couple cents, but all of it adds up. Play some important roles in the RF infrastructure. So it's a pretty cool company. What I always get bummed about is every time a new phone comes out, it's all about the screen, the camera, and all that cool stuff that everybody sees. But what actually goes every year when a new phone is released is a whole lot of design work. That whole RF architecture is really redone every year. We're getting out more power and reducing current. Brings in a whole lot of challenges because every year we have to re-win our business, basically. And we have very steep product ramps. So what that means is we'll spend maybe 2 years developing a product, and then in that 2 years we will maybe make, I don't know, 10,000 to 100,000 parts, depending on the customer and the development work. And then after that 2 years, we get ready to ramp into production. So within 1 month, we will go from totally building at the most a couple 100,000 parts. We're going to then start building 100,000 per week, and by the end of that month, we're typically building maybe 1 million to 4 million parts per week, depending on the customer and the parts. So very steep ramp. We need to make sure that as soon as we go into production, that we're not going to have any quality issues, because they can become very costly very quick and really impact the customer's ramp. The other thing is very high quality expectations from the customer. Now, I came from automotive industry. I've been with Qorvo now about 10 years. Before that, I was 10 years automotive. And one of the things I thought when I came into consumer electronics is this is going to be so much easier. I don't have single-digit PPM expectations for meaning, less than 10 parts per million fail. What I found out is really hasn't become too much different now in consumer electronics. Everybody expects that their phone to work. Right? If you plug it in one day and it doesn't turn on because parts shorted out, right? Consumer's going to be upset and it's going to affect that company. So more and more now, there's really not much difference between the automotive quality expectations and the consumer electronics expectations. So trying to balance that high quality with a very quick product ramp, it involves a lot of challenges. So we do a couple things to make sure the customers stay happy as we're going through all this. One, we do a lot of focus on quality and development. Right, so from the time we initiate the part development, we have quality engineers that are overseeing that process, maybe not overseeing, but involved in the process and thinking of ways that things can break. They're working with our manufacturing teams to make sure any new manufacturing processes we use are manufacturable, that we don't have very low yields, that we can actually ship when we intend to, and we don't have unplanned quality problems. So hopefully that all goes well, and then we'll move into mass production. And when we do, then we have a lot of monitoring we do. And what we really hope is that this isn't needed and it's really boring. We don't find anything. That would be their best case. But we look at both yield and reliability monitoring. Reliability monitoring means we will build up parts and then we'll put them into a stress test, maybe a temp cycle, range from -40 to 125 C, and do that every hour for 1,000 cycles. Make sure the part still works. And we'll do that every week, maybe a couple hundred parts. The other thing we do on every lot is we look at yield, and we make sure that it's acceptable and it's normal. So that's what I want to talk about today, is how we do our yield monitoring. It's been the process controls that go along with that. So what we found in automotive is failures are really giving signals every step along the way and every yield point that we have. So here's a pretty simple process flow, right? We got a generic integrated circuit there that's all packaged up. That goes into an engine control unit, right? So we'll send it off. I actually worked in that first box. My customer there was the engine control unit back when I was in automotive. And then that would get tested, and then that lot would ship out for vehicle assembly. The goal was when you turned on the car at the end of the line, you could drive it off the line into the parking lot. Well, if it didn't start up because of a problem with the ECU, you'd have failures. They measured them in PPM, or parts per million. And then they would go back to my customer and said, hey, we had these couple failures. Customer would start investigating it. And often what they would find is they would have maybe 100 PPM of failures in their line. Right? It might have been lost in higher yield issues, right, that they normally see. They would send that information to me, usually on like a Friday at about 3 p.m. It's very nice of them. And as we would start looking into what was the cause of the failure there, we'd find similar issues at a higher level in our line. So what this really drove through the industry is to monitor those yields and be very critical of every lot that we send on. Right? Parts are manufactured in lots, so there's a group of them, maybe depending on the part, from 10,000 to 30,000, and we monitor those yields. So and it really comes down to 3 steps for this yield monitoring. First, we want to identify lots that are different, right? And then we want to investigate them and understand why. Why are they abnormal? Maybe it's not a big deal. The last thing we want to do is disposition them. We can't just keep holding them and say that they're different. We need to figure out, can we ship them? Do we need to scrap them? Can we rework them? So to identify abnormal lots, anybody familiar with statistics here? Six Sigma, right? So you just, here's a plot of different lots, just generic plot, and our yield. So it looks like we're yielding pretty well. You can always do an average, right? And then a -3 sigma from that average. That's an okay way to do things. The problem with yields is yields are pretty one-sided distributions. If you look, our average here is probably like 88%, but you can never have a 105, 110% yield. That distribution is going to be really skewed high to that one side and then with the tail off lower. So a -3 sigma limit, well, you might catch that part, right, depending on how you calculate that. It's interesting what our statisticians at Qorvo do. They really don't aim for a 3 sigma or using some interquartile. They really backtrack to that method, and they really just look at a yield chart and say, where's the right place for it to be, right? And the human eye actually, when you're thinking of trying to find outliers, is pretty good at determining where that line should be. So a lot of the calculations that we have into it are actually just trying to mimic where somebody would look at this and say, what looks abnormal, where should I put that line? So now we've identified something. Now this can be on an overall lot yield. We also do this on individual tests, things like leakage, contact. We want to detect if there's a high number of shorted parts. Things like that are good indicators of a latent quality issue. So then we start investigating it. So there's a lot of things we can do in the investigation. Typically, we start out with data and physical analysis. So we'll start looking over the test data, and then we'll submit parts to FA. We typically find 2 types of things. If you look at these test distributions, right? So I just have a test value here in the count. So the higher here, there's more parts at this test value, and test limits there in red. Sometimes we'll just see a shift in the distribution. Right, just maybe normal process variation. We'll get some more parts that are a little bit lower in output power, have a little bit more leakage. We may look at that and say, that's not a quality concern. That's just variation. We can even do some FA to verify that. The other thing we can see is a bimodal distribution, where the main distribution is still centered within the limits, but now we're starting to see this second group of parts pop up. Typically, whenever I see that, I start getting worried. Just what's driving those? And depending on the parameters, too. If we start seeing parts that have no power output, or they're shorted out, have very high leakage, it starts getting us worried that there's a quality issue. So those are the types of parts that we would submit for failure analysis. Once we have that information, right, we're going to figure out how we're going to disposition these parts. Now, they're different, the yield's different, but that doesn't make them bad. There's a lot of parts that just have lower yield, like I said, because of process variation. We don't just want to chuck everything that's different in the garbage can. So we do a lot of work then to figure out what's causing that and then determine what we can do with it. We can test the tighter limits and maybe weed out some of that stuff right on the edge of the distribution, or we can just scrap it. Maybe it is bad, maybe it is a quality concern. Some parts we do just select to send on as is. An often favorite is just, let's just keep them there, continue to investigate, and we'll figure it out eventually. So basically, that's how we do things. I think more interesting now is going into actual case study. So this was a fun one we've worked on before. So we're ramping up a new power amplifier module or pad module for a large customer. These are pretty neat parts. This one, I think I had about 50 parts in the BOM, and it measured about 5 millimeters by 5 millimeters square. So parts included power amplifier, gas die. We had a silicon CMOS controller. We had switches in there on SOI. We had these bulk acoustic wave BAW filters for RF filtering. And these were all then mixed with surface mount components. They're put on a small board, a PC board, soldered down, and then overmolded to give you that little integrated circuit that's that we ship out. So talk about that BAW filter. So this part right here is much larger than it is in real life. That BAW filter is typically about 0.7 by 1 millimeter. These can get pretty small. You can get them mixed up with pepper if you drop them on a table. The way we connect those to the board are with these copper pillars. So these black circles here are actually plated up copper, then with plated tin on top. So we would make a wafer. So there's a round disc that may have 10,000 of these on one of these wafers, and we plate up all these bumps. And then when we go to assembly, we'll flip them onto the board, reflow them, and overmold them. Well, so we started up this ramp, big customer. This is a very important part, very complicated, and we start monitoring. Right? We start looking at the yields. So this chart was the actual yield, and each color is a different work week. So you can see that ramp that I was talking about, where there's not a lot of lots in the first couple weeks, and then it looks like about 5 weeks in, we hit some big volumes. And things went well at first. But about 3 weeks into high volume, we started getting a whole lot of fallout here, where our limit was 99.8%. So this is a leakage test, which we expect to be very high. And we started getting up to 10% fallout for these. So it was a huge concern. I think we actually shut the line down for a little bit as we were investigating. And we pulled out parts and performed FA on them. All right, what we found is, we talked about that copper that's plated up there for the interconnects. Well, there was extra copper that was shorting between those two bumps. So here's a reference, and then the deprocessed part. So what we're looking at is the bump, another copper bump or copper pillar. There's test pads here, right? And then on the deprocessed part, now, one, it looks ugly because it's been in a overmolded package and you have to use mechanical polishing and then acid to decap it all and expose it. But you clearly see all this copper here, right? That should not be there. So once we started running the part, you have the ability for the copper to migrate and actually short out those two pillars. And that's where we're seeing the leakage. It's kind of interesting. This was a RF port, so we're actually putting DC through the antenna pin. It was actually testing another part elsewhere in the module, and testing out some capacitors there, and making sure that they were there. But we were able to see leakage here, so it's kind of neat. We were testing one part, and we were able to see a signal somewhere else. So now we know the root cause, right? So it looks like our yield monitoring has worked, right? We had abnormal lots, we caught them, we were able to stop and look at them and figure out what happened. The fab engineers were able to go back and figure out why we had this problem and fix it. But what we started looking at is, well, why did we even build them into modules, right? Similar to how we had that 3-process flow earlier with the integrated circuit fabrication and then the ECU fabrication. Well, these parts are made in our fab, and they go through electrical test and an optical inspection, and then they're shipped to our assembly site where we put them into that multi-chip module. We started wondering, well, why did we even build with those to begin with? We started looking back at the yield signals back in our fab. Electrical looked okay, but as we looked at the automated optical inspection, we found it wasn't so good. So this is a pretty cool machine, right? We have a wafer with these 10,000 parts on it, and it has a camera, and it will scan through, take a picture of every single part, and compare that to a known good part. And it will actually compare pixel by pixel if anything's different, and that's how it defines a defect. Well, what we saw wasn't so great. Here we had most of the lots are down near 0%, maybe a 5% yield loss actually. Sorry, this chart is backwards. But we had a number of lots, especially a couple weeks in, where you had these wafers with, look, up to 20% loss at a visual inspection. And although we knew to look at the module level, we weren't looking back at the fab level for the AOI inspection and seeing, was there anything abnormal there? But one of the things we started talking about is, well, if we're inspecting them out, why are we ever seeing a problem? Right? It's taking out all the bad die. All that's left is good die. So here's a wafer map. So there's 10,000 dots on there. You can count and verify if you'd like. The blue die are the bad die. Those are the ones that the automated optical inspection machine said was abnormal and screened out. we started looking at some of these wafers, because in the middle of that blue splotch, maybe is the technical term, you have a bunch of good dye, right? So we went and started looking at those, and lo and behold, they weren't actually good. They were getting through our containment. So this was one of the dye from that area, and you can see copper in between the two pillars. So we had a containment that wasn't 100%. So we went back learning from this and did a couple different things, right? We created an improved automated optical inspection program. So in green now, we can capture more of those dye that have the problem, pretty close to all of them. So enough that we could get an even higher yield signal if we had a lot through that had this issue. We also just implemented yield monitoring. Did the same thing we're doing at the final module level, we did at the wafer level. And we're able to capture lots coming through that have this issue, and we don't send them on and don't build with them. And the difference when we capture something back at the wafer level, we're talking about parts that are a couple cents to parts that are in the dollar range once we put them into the module. So it's very important to catch them early. So now is the tough time. We built all this stuff. We want to know if it's good or bad. So we started with our disposition plan. We said, well, we'll do reliability testing. We have all these cool tests that really stress the part and figure out, hey, are these things going to fail for the customer? So there's a number of different tests we did in pretty high quantities. So typically to qualify a part, you're doing 77 pieces in each one of these tests. Here we took 2 different lots, and you can see we ran 40 to 240 parts through each test. HAST is a neat test, so we're actually putting it at high temperature and then pressurizing it to force moisture into the part. You had a question? 5 minutes? Okay, I should be all right. So we went through all these tests and had no failures, right? So success, we could ship those parts. Then it was pointed out, where did those parts come from? If you remember that wafer map, well, there was a whole lot of good area on that wafer map that wasn't affected. So did the parts that we tested come from here? Or did they come from outside of that area? Well, we really didn't know. So that forced us to actually go back, be a little bit smarter about how we picked parts. We came up with a new disposition plan. So we wanted to pick die that were next to those bad areas because we knew that those were the ones that were getting through and getting built into our modules. So we actually came up with 3 different groups here. So the red was the AOI. I switched it around on you from the last one. Blue was good now, or bad before. Now red is bad. The light blue are ones we decided to build into modules to determine, hey, are those parts that we shipped out in that area good or bad? And then as a backup plan, we took these dark blue parts and said, well, worst case, we can exclude all that light blue area and just ship out the rest of the wafer. We could use those parts to build, kind of limit the impact. So we built up these parts, ran it through, and depending how you look at things, it was either good results or bad results. It was good because we got a signal there. From the light blue area, that middle area in between all the bad dye, we did have a failure. We were able to do FA on that and find that, yeah, it had the same issue. All right, so unfortunately, the parts that were already built up, we couldn't save. They had bad material in them. There was no way to screen those out, and it's going to be a reliability issue for the customer, and we had to protect them. But we did find that we could save portions of those wafers that we had built up that were affected and use still a majority of those dye, so maybe not a total loss. So we learned a couple things, right, that all these yield points are meaningful. We've been implementing more and more of these now in our process. And anywhere we're taking a yield, anywhere we're doing measurements, we want to look at that and say, are those parts abnormal? And let's catch those before they get to the next customer, whether it be an internal or an external customer. We also really question our effectiveness of our containments. When it comes to reliability issues, tests are often good at catching parametric problems, parts that are bad right now, but it's very hard for an electrical test to catch a part that's going to fail in the future. We're talking about a test that may be in the 500 millisecond range that is going to be used in a part that's going to, in a phone, run for minutes. In their test, and then hours and hopefully longer out in the field. So we really need to make sure when it comes to latent issues, we rely on the yield data to identify bad groups of parts, because identifying bad individual parts can be very tricky. All right, so I think I'm about out. So now one of the things I do as customer quality is I often talk about things other people do. So there's a couple great engineers that actually did a lot of this work that I got to talk about today. So I'd like to thank them. If you ever see Harold or Zhao Kong, they're in Texas, so maybe they won't be here today. But thank them. All right, any questions? All right, thank you.
I actually have a question for you.
Sure.
You had an orders of magnitude kind of chart showing how the number of parts per million changes. I would expect it to be the opposite. Like if you were going from the IC and you have a certain ppm yield loss, then you integrate into something else which has a whole bunch of other parts. Wouldn't that integrated thing have a higher yield loss?
It could, depending on the defect mechanism.
Okay.
Most defects, right, you have a higher level right as you first test them, right? You have some that are just bad right off the bat, as we saw in our actual electrical yield loss. But that weeds out a whole lot of the parts. So in this case, think of it, the example that I had, there was metal that was very close to being shorted out, but not quite shorted. So some of those were different lengths and distances away. The ones that were shorted right away would fail very quickly.
Oh, so this is after you've weeded out the bad ones.
Right.
Okay.
Yeah.
I get it. That makes sense. Great.
Well, I guess this is weeding out the bad ones.
So the step between 1,000 ppm to the 100 ppm, you've tested a bunch, you've thrown a bunch out, and you only send the good ones on.
Right.
And that's why it's a lower number. Okay.
Well, yeah, we try to send the good ones on.
Got it. Yeah. Okay.
Thanks. I had a similar question, which I think you've now answered. But just to be clear, so the way I decided that I should interpret this slide was that's kind of what you're aiming at on the way out is that's right. Your chips, if you had 1,000 ppm yield loss at the chip level, that would be okay. But if you had 1,000 ppm yield loss at the ECU level, that would be really bad for your business, for your ECU business.
Exactly.
And so about 100 ppm is about what the ECU business can cope with when they ship their parts out, right? And when you're shipping the cars, is that a right way of thinking about it? You want even lower.
Right. You want 0 at the cars. So the target everywhere actually after our module is 0. Right. It should be 0 for catching everything right off the bat.
So is this yield loss strictly due to that IC, or is it the yield loss for the entire integrated product? So tires, headlamps,
right. So this is looking at for this issue on the IC.
I see. Okay, that's why I was confused then. Okay, great. Cool. Let's thank Brad one more time. Thank you.
Thank you.
I'll also mention that upstairs in the demo area in the commons, there are a few projects. ORSAT is there, and which is, if you were here last year, they talked about open source space. They're putting a 2U CubeSat up there in a year. And then Lime Microsystems has a bunch of demos. One of their latest projects is Radio Front End. Both those projects use a bunch of Qorvo components, so you could go actually see them on the board. So check it out. Thanks, Brian.
Yeah. Thanks. Oh, I got 2.
Oh, you got one. Okay.
Yeah, we're getting the slide set up.
Oh yeah, here we got 2 mics. Hello, hello, hello. Okay, yeah, we're good.
Yeah, I thought
we're good. Yeah.
Hello, hello.
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 Hi. You guys are in for a surprise. I'm not sure we know what's going on yet.
Yeah, no, we're not starting yet. I still have to finish my slides.
You have HDMI, right?
But now that you're in here, you can't leave because we're watching you.
HDMI?
Yeah, give me a second. I gotta do one thing.
Kelly will make an announcement so you know what's going on. And then you can leave.
Oh. Where's your HDMI? Other side?
Will, are we going to be in the way of the slides?
No, we're gonna be fine.
Well, okay.
That's all.
The slides aren't what you think they are.
All right, ready?
We're currently still setting up slides for this upcoming talk.
Hurry up, man. I'm almost done. This should give you a good example of how this talk is going to go. Yep.
Do you remember to turn it on? Do you turn it on and off? Oh.
Do you know, were you ever handed the second mic again?
All right.
Do you know? Okay.
All right. Just let me know. Oh, let me.
Oh, there is one. Oh, hold on. And now, we have Fireside Chat, hosted by Will Carana, and today's special guest is Joe Grand.
Explain why we're here.
Hi, Joe. How we doing?
Hi, good. Do you want to tell the lovely people who are here, probably not for this, why we're actually here?
Oh, for the e-ink display, right? You're going to talk about this. Go ahead. Talk about e-ink.
So this is e-ink. It's a zero-power display with a serial interface. I'm guessing because everything has a serial interface. We are not the people here to talk about e-ink.
Definitely not.
Right.
Zach had an emergency, so we decided to fill in. I'm so sorry, and I don't know why any of you are still here.
So actually, we'll give you 5 seconds to walk away. We won't look. But this is an off-the-cuff interview. Somehow, we just happened to be sitting out there at the wrong time and got selected to do an interview. So he's going to interview me, I think.
We are always together at the wrong time. Let's go to the next slide and see what I put in. Oh, you made a badge.
Yeah, okay. So this one is, for those who are wondering what the hell's going on, my name is Joe Grand. Some people know me as Kingpin, and I design things and teach about hardware hacking. This badge, which is a really weird picture, is the latest DEF CON China badge, which is a flexible circuit board with basically an Arduino Mini and an FPC connector on the side, a little edge connector, where the concept of designing this badge was for DEF CON China is basically the first time that DEF CON has been over there, the world's largest hacker conference. And we wanted to do something that kind of brought the community together. So we're like, all right, let's build this badge that's sort of simple, but still lets people kind of do something. So this edge connector, as you go around the conference and complete different tasks, like the car hacking village where Will was, or lockpicking village, you plug the edge connector into a little Arduino that does some serial communication and enables one of the lights of the root. This is a tree, if you can't tell. So as you light up one whole root, then part of the tree lights up. And as you complete all 16 tasks at the conference, then the whole tree lights up and blinks in like the sparkle mode. And this was a flexible circuit. So the first time I'd done any sort of real production manufacturing of flex, the glasses I'm wearing, which you might not be able to see, are my first run through Osh Park. Flexible glasses. I have a sunglasses version also that just has the Kapton polyamide in the middle, which does actually darken, but I don't know if I think it still passes UV, so I wouldn't recommend actually wearing them. But yeah, so I wanted to do something flexible, something fun, something simple that people can hack on, and that's this badge.
Now, one of the things, so I was there at DEF CON China, and we definitely thought we're going to lose some LEDs. I don't think anyone in the car hacking village actually lost an LED on their badge. Did anyone report any kind of malfunctions like that to you?
Yeah, so the only failure we had was not the LEDs, but down at the USB connector. So these are micro USB, which Joe Fitzpatrick, another Portland hardware hacker, would be very proud of me for using these because I hate micro USB. I always use mini USB just because it's bigger and easier, but seems like everybody's using micro USB. So the pins are small. One thing I learned about designing Flex is I use Altium Designer, and there's a feature in there called teardrops. And what it does is basically takes every intersection and kind of widens them. So imagine like if you have a T, it's going to add, I don't know what they're called, fillets, curves or something. So the mechanical strength is better for Flex. So I ended up doing that, which strengthened a lot of the other connections. But just in that area, when you're putting in the connector a lot, it could get pulled off. So a few people had damaged their micro USB connector. But the great thing, being at DEF CON with the hardware hacking village, is like, great, go fix it yourself. And then they just reflow it. But the rest of it, like the connections are pretty good, and you can flex. I don't want to do this one because it's the last one I have. But you can actually bend it all the way around in a circle, and it will still work. And one trick, if you are going to do flex, especially because Oshpark now offers it, is you can use a copper pour to just increase the thickness where you don't want it to flex. So all the electronics that are down in the center here, I just have a copper pour, so it just makes it stronger without needing to do like an actual stiffener on the side, which we do have the stiffener on the side for the FPC because you need that to get the thickness to fit into the connector. But all the rest is just straight up flex with stuff on it.
So we have the cube room. Now, did you have a hand in this?
Yeah, so part of the thing is we wanted it, each person to have their individual lights, but then the DEF CON, the people that were arranging DEF CON in the US and then the sponsors in China wanted to have something like bigger. So they hired some artists from New York to build this giant shipping container with this art inside. So you go and plug your badge into it, and that kind of shows the community view of how much people have done within the conference by building like a digital tree. So you put your badge in, and then it creates a leaf for every person, and then that leaf will show the number of LEDs you've done. So my only contribution to that was, sending them the interface they needed, and then working with them on the badge communication, so they knew what data they were getting, for this. And it was awesome. Like it really kind of made it fun to see over 3 days how the tree went from like this bare tree to like leaves everywhere.
Thank you.
Oh, more stuff. Oh, I do want to mention too. Let me mention this about Flex. This is something that actually you'll run into. Normally you get boards made and it's like, oh, I need to, cut a trace and add a wire like Alvaro did a million times in his weather station. Because you're prototyping and it just makes sense, right? It's like you build prototypes, you expect that to happen. With Flex, you can't really do that. So I got the prototype back and I'm like, oh crap, one of my footprints was wrong on a transistor, of course, because it's always that. Like a SOT23 3-pin package, it was messed up. So I had to flip it over, cut some traces. But what happens is when you cut through Flex, your substrate is like, I don't know how many microns thin, but you end up cutting through both layers. And I had a ground plane on the backside, so as I cut through, I'm now shorting my traces that are touching the ground plane. It was a nightmare. So if you are going to do Flex and you have a need, you think you're going to need to debug, do a thicker version first that's not Flex, and then maybe go to Flex. I got lucky and was able to use some super glue to prevent kind of build a barrier in there, but it was like pretty hairy for a while. I got to the point like I was almost in tears of like, I have 3 weeks to finish this or whatever it was, and like, this is horrible. I hate engineering. And then it magically was enough, and then it ended up working.
Did you try sandpaper? Like, would that also go through?
No, sandpaper actually would have been a good idea, because probably to lift that one trace. You're amazing. I should be interviewing you.
All right.
I'm trying to think. Actually, well, that was on the circuitry part just to make it thicker. So I didn't need it electrically, but it was to make it thicker. And it was just unfortunate, but it worked. It worked enough to make sure that's what it was. And then I fixed it. But it was funny when I got the pre-production prototypes back, that was the first thing I looked at is like, is my fix actually fixed? And I go and plug it in. I'm like, oh my God, it was exhibiting the same behavior. And I'm like, oh no. But it turns out that I forgot that I had to program the FT231X, which sets it. It's the USB to serial adapter, and I use the I/O pins to enable power of different things. And I hadn't programmed that yet, so I was like too excited to test the fix, and my heart just like went, and like I got really nauseous. And then I was like, oh, I got to program the part. And then I programmed the part, and then it worked. So, disaster averted.
That's the story of your book.
It's the story of my life.
All right. So, all right. Tell us the secrets now. I want all the new DEF CON secrets.
Okay,
What's inside those boxes?
So these are some materials for the DEF CON 27 badge. Let's see. I guess 13 years ago, I designed the first electronic badge for conferences, and that was at the time. Nobody had really. So many people were into software still, and like the community of making things wasn't quite there. So I had built originally. The short history is I had a little G-shaped circuit board in the shape of my logo that I use for a training class that I give. And the Dark Tangent, Jeff Moss, who runs DEF CON at the time, also ran Black Hat and was like, hey, that's a cool badge. Like, we should do something like that for DEF CON. And I'm like, okay, like, do you think people are going to like electronics? And he's like, yes, of course. Because he seems to know, he's like this visionary of like, he knows exactly what's gonna be, interesting. So we designed the first badge, and then over 5 years, we did different badges and like lots of crazy things, aluminum substrate boards, laser engraved, some e-ink from a company called Kent Displays. So it was before you could really get e-ink. This was like a zero power, really awesome display. We had infrared communication and capacitive touch and scrolling LEDs, like all this crazy stuff to basically just get people excited about electronics and hacking them and things like that. So I kind of retired from that at DEF CON 18. After DEF CON 18, I was like, I'm done doing this process. It's hard. I want to do something new. I was like tired of kind of one-upping myself, and I put a lot of pressure on myself of like, what, are people going to like it? Because my whole thing is like, I want to design things that are fun for me, but I also want to kind of not impress my friends, but I want my friends to appreciate it and use it and hack it.
You always impress me, Joe. Don't worry.
Thanks. But it's like, it's like harder when you're giving a talk in front of friends than it is thousands of people, because they're your friends.
Stop caring about the thousands.
So I just kind of stopped doing it and let, the badge life thing went off crazy, and it's amazing. So it's like my purpose, I don't need to be there every, doing it all the time. Other people are doing it, and it's great. But then the Dark Tangent, out of the blue, contacted me, and I was always like, I'm never going to do another DEF CON badge unless Jeff asks me to do it. And then this year, out of the blue, he's like, hey, can you design the badge again? And it was a perfect timing, again, being in the wrong place at the wrong time. Like, I was traveling a lot last year, teaching classes, and like I just wanted to stay home and like see my family, and it would be great. So he just got me at the exact right time. I'm like, yeah, that sounds awesome. Let's do something again. Let's do something like really simple, but still really fun. And it always starts off simple, right? And then it just sort of devolves from there. And like seeing my family like I see them more when I travel than working on this badge.
And you're almost done now.
Almost done. So the hardware, we just kicked off hardware manufacturing on Monday. I had six days to test the prototype when it came back. I'm not obviously going to give you too much info.
I think you should. Come on, guys, right? You should give us all the info.
But this one, so very, very complicated. We got the boards back Monday after being in China for 2.5 weeks without, real internet connection or anything. So I'm trying to do some software development on my burner laptop, get the hardware on Monday, test it, revise the circuit board, and then place the production order a week from Monday. So that was last Monday. So we went from 6 prototypes to 28,000+ without any intermediate pre-production prototype tests or anything. Everyone shaking their heads, and it's like, better me than you, right? Like, it's crazy. And if you knew the amount of money that it costs, like, it's stressful, especially because I know Jeff, right? So it's like I'm spending his money. Yeah, totally fine. Yeah. But that's the risk you have to take sometimes of like jumping from manufacturer. Like, we don't have the time and we don't have the money. Like, we could maybe do a 2-day turn, fab and assembly to get one built, but it would be thousands and thousands of dollars. And it's like, all right, let's just spend all the money now and see what happens. So hardware is done. Firmware is almost done.
Almost done.
I have until July 3rd. It's totally fine.
Let's talk about almost done.
And like, this is actually, I haven't showered in I don't know how many days. Like, for those of you who think that like, engineers take I don't know, like, it's what they say about engineers is true, right? Like, I'm just like you.
I want to be real clear about this. Everyone should shower at least once a day.
I haven't.
Like, I have a lot of respect for you, Joe, but what are you doing?
I'm married. Whatever. It's fine. I just sleep in another room. But it is one of those things. It's like this crunch time, and it's been like that for months. And like I'm like an absentee father. And my kids are like, "Oh, you still working on DEF CON?" And like when they came to China with me, they actually got to see the final thing and understand like, oh, this is how it's done. Like, Daddy does something other than just sit in front of a computer. Like, they got to see me on stage. That was fun. But this one still is at the point where they're not really sure what it does. And actually, I'm not really sure what it does either. So I got to work on that still.
All right, so let's talk about plane hacking.
Oh, yeah. Actually, there's a plane hacking village at DEF CON this year I've heard about. I'm not going to bring this because it's too heavy. Did I take that picture?
You did.
Oh, yeah, that's my hand.
I stole it from your camera. A lot's happened since I last saw you.
Yeah, this is amazing. So let's see. This is some weird, I don't remember the name of it. It's like one of those modules from the airplane where it's like the terminal part and the keyboard that communicates with other subsystems in the aircraft. I got this from... there was like a production studio somewhere in Portland going out of business. They had made, I think it was The Librarian movie or TV show or something like that they were filming here. And this was a giant warehouse sale. And I found this thing and like it looked super cool. So I would like to do something with it. The back has this crazy connector that I don't really know what it is. So it's been sitting on my desk. But it'd be nice to use it as a display or something. And this is the type of stuff I like to do, like hacking on things for no other reason other than like for fun.
Have you powered it up yet?
I haven't powered it up. There's no obvious power. Like everything's in that connector.
Well, I don't know if you took it apart and actually looked through to see.
I might. It's like when I stop accepting ridiculous projects to do, then I'll probably do this one. But I'll take a picture of the back and bring it to DEF CON because I think it's a it must be some industry standard thing like CAN bus, but for aircraft.
So yeah, planes do run CAN.
Maybe there's CAN on the connector.
Yeah, I'd love to.
Maybe we should join forces. Yeah. Come to my house.
Let's talk not on camera about this.
Okay. Yeah, we wouldn't want the plane to go sideways or anything.
You were on TV?
Oh my God.
Wow, no.
I haven't seen any of these slides, by the way. I assume you know that by now. Will just like totally made this. Yeah, so a long time ago now. But still relevant. I was on a show called Prototype This, and this was 4 engineers building ridiculous prototypes of things. And it was on Discovery Channel, and it was really like a cool way to share engineering with the masses, like show people what is engineering really about and prototyping and building stuff. And it was not that much different than Alvaro's weather station. It's like you hack stuff together and it works, and then you make modifications and you do it again, except we didn't have 2 years to do everything. We had 2 weeks per episode to build 10-foot giant boxing robots that would move based on the movement of players outside the ring, or a mind control car. That was kind of silly, but we had like this headset that was designed for game control. I don't remember what game system it was for, but it would like read your mind through, I don't know what it was doing, taking some measurements and like fingerprinting something. So we'd use that to start the car, and like a truck that could elevate itself and drive over traffic. I don't know what else, like a water slide simulator. So just crazy stuff that was like mechanical, electrical, software. And it was super fun. And at the time, it was like it didn't really seem that fun because it was a lot of work, and we would engineer and then have to be a host and like explain stuff. And the producers were like, come on, when's that going to be ready for us to test? And we're like, we have to build it. Like, stop talking to us so we can build the thing. And they didn't understand failing. Like, they expected every single thing to work every time. And we're like, that's ridiculous. But they didn't they're not engineers. And so we had to spend like the first probably 3 months out of this 1.5-year project trying to explain the process. And over time, the episodes, I think, got better because they understood the process more. And we actually failed on one of them. I won't tell you which one. But we failed on one, and they're like, oh my God, what are we going to do? We can't air the episode. And then, they're like, just watch, the editors are like, just watch the episode. And the producers were like, this is great. This is like, I don't remember the suspense or, some TV term. They're like, they have to fail more. And, but it actually made it real. And like, that was really fun. And if they had, not pulled the show, which they did, we would have built other stuff. But it turns out that engineering's expensive, right? And like, we weren't even the expensive part. The film crew, I think, was like $100,000 a day. And we burned a lot of money in what they thought would be a 6-month project, was a 1.5 years. And they wanted this to be like the next Mythbusters because they thought Mythbusters was going to kind of, whatever, go down. And I don't know. It was like it was hard at the time, and now I watch the episodes with my kids, and I was like, that's so fun. Like I want to do that again.
Should I watch it?
Oh my God! Of course, I'll give you a DVD set. Whenever you,
That's okay.
Whenever you come to my house to hack on the airplane thing, I'll give you one.
I'm good with
DVD
it.
sets available on eBay for like $6, and on BitTorrent. I don't get any royalties, so steal it however you want. I don't care. Just watch it. Like every kid in my neighborhood has a set, and it's amazing. So yeah, I mean, it was a fun show.
Now, I told Joe I'm going to ask him like the hard questions, the one he doesn't want to answer in front of a crowd.
There is.
Were
no
you
such thing.
kicking rocks off of a roof?
Okay, so some backstory. There's a new book that came out called Cult of the Dead Cow, how the world's greatest hacker group saved it, whatever it is, about CDC, Cult of the Dead Cow, big hacker group back in the day. And there's a lot of overlap with the group that I was involved with called the Loft Heavy Industries out of Boston. This is a very early picture when some of the first hackers back in Boston had met this was like 1990 or 1992
There's
or
no
something
date on
like
there,
that.
don't worry.
No, I'm just looking at the T-shirt because, but the city looks a lot different now. So this was something, and in the book there's a history of the Boston hacker scene, which I'm a part of, and the Loft, and they say that at this particular event, I, being the juvenile delinquent that I was and am, was kicking coal off of the roof onto people, and the cops got called, and the cops came up and told us to stop, or someone was going to jail. I don't think it was, and I told this to the author of the thing too, and he talked to everybody there, and I told him, I was like, I don't think I was kicking coal, because like I'm not an asshole. Like
you heard it here, folks.
I'm a troublemaker. Like I'm not an asshole. I'm a troublemaker. Unless I don't like you, then I'm an asshole. But to people walking on the street, like throwing cookies was more my style. And I told him that. I was like, I was probably throwing Chips Ahoy cookies because that's what we had here. But he put in the book, he put coal. And then as a footnote, it's like I talked to multiple people that said whatever. So it just, I don't know, whatever. But that was a fun time back in the hacker scene.
So what was your favorite freaking exploit?
My favorite freaking exploit. So one of the things that I would do a lot as a kid is we'd set up what were called alliance teleconferences. So where we basically had, it was a party line, and we'd have, you know, people from all over the country in a chat. And I didn't know the cost of this. It was run by AT&T, sort of business line conference calls. And Jason Scott from the Internet Archive had talked about this recently. He said that the cost was $5 per line per minute back in the day. And this was not uncommon. Like I wasn't the only person doing this, and other groups were doing this also. But so you would set up a conference on somebody else's phone line and then call all your friends, and you'd be on there for like 8 or 12 hours, like all night long. And you'd prank call people. You'd call girls or boys that you weren't flirting with, whatever. You'd call radio stations, and you'd just like fuck with anybody that you could, because you're on a conference call. It's hilarious.
Did you ever call an elevator?
No, we never called an elevator, but we did actually connect a bunch of directory assistance operators together. So they're all like, 411, how can I help you? And they all are like, what? And then they end up talking to each other of like, I'm in Houston, I'm in Boston. And it was awesome. So like we're bringing the world together. And who knows, like maybe they made lifelong friends. I don't know. But part of that, the way that I would set up the conferences, because everybody did their different ways, is I would ride my bike into downtown Boston and go down one of the alleyways where they had the phone boxes connected to like all the apartments in one area. And they were usually locked with a hex wrench, so you just had a hex tool. Open that up, have my lineman handset, connect up to that, start the conference on somebody's line. And then once I was up, I'd call my friend, transfer the control of the conference to him. So now it was being billed to the apartment, but controlled by him. And then I would close it all up and then ride my bike back home. And now we had a conference. And I can't even do the math of how much that would cost per night. But like, I always figure with all that mischief that I did back in the day, and that a lot of kids did back in the day, whether it was like stealing other free phone calls and all that stuff, is like no person paid for that. It was just these massive companies that shouldn't have been charging so much anyway, and they should have had better security. If like a 13-year-old kid could go and get a free one. So I feel no remorse about any of my past.
So let's talk. Did you cheat at video games?
Yeah.
What's going on here?
I've been known to break the law and question the law. I also cheat on video games because I suck at playing games. This is the Game Genie for the NES. I love retro games. Portland Retro Gaming Expo. If you're in the area in October, go. It's awesome. PRGE. Woo. So this is a Game Genie. I have not the normal toaster. No, not the normal. What do they call it? The toaster. Nintendo NES. I have the top loader, which is like the second version of that, a little more reliable. It has composite out, I think, already. There's some other benefits. I don't remember, but I have one. And the problem is, so I started playing video games with my kids, who are now 10 and 7. So I'm introducing them to like the Atari 400 computer, NES, ColecoVision. I did, just buy them a Wii because they like Mario Kart. So they sort of took a few leaps up in technology. But I started them off with this stuff, and we were playing like Super Mario Brothers, track and field, and some other stuff. And since I'm so bad at games, like they wanted to see me win Punch-Out. And I'm like, guys, this is like really hard. And I don't want to play for 12 hours playing Punch-Out. Like I get bored. I'll play one level and I'll get bored. Like I just don't play games. So I was like, there has to be a better way to do this. And I remember, the Game Genie. The problem though is the Game Genie doesn't work well with the top loaders because the thickness of the circuit boards that the Game Genies use, I think it's 62 mil. I think it's the standard circuit board thickness, where with the toaster version, it's fine because it goes in and then the fingers close onto the connector. But the top loader, you have to put the cartridge straight in. And Nintendo cartridges are 47 mil thickness. So I couldn't stick a normal Game Genie directly in because it would then break the connectors. You won't be able to get it out. And I didn't want to do that. So I just made a little circuit board, 47 mil thickness, and just extended the line so I could then have a female connector on one side that I ripped from a different Game Genie, plug that into the male side of the Game Genie. Then I could plug this into the top loader and then plug my game into that side. And then we could cheat on a top loader. So it was perfect.
Wonderful.
And that was a lot of time for, then I won Punch-Out.
I would expect you would.
We did one of the cheats where it basically wins no matter what.
I think you would go back one.
We're almost done. You can almost leave.
Yeah. What is going on here?
Where'd you get this from?
I was on your computer earlier.
Which is at home, so that's really scary. It wasn't even the one I brought to China. Did you put malware on it in China? No, this wasn't even the same one. Was this on Twitter?
Don't worry about it.
I don't even know where that's from. Okay, so this was a prototype of Kingbright released some cool color LEDs. So, they released, I think they call them special colors or something. There's pink, purple, sapphire blue or something, non-standard colors. And some pink ones came out. And there's a tool that I made, a hacker tool called the JTagulator, which is basically a tool that lets you connect to unknown test points on a circuit board. It will enumerate through all these possible permutations to detect and determine what the proper pinout is for JTag or for UART if you want to hack on the board and like find the interfaces, which is a pink circuit board, which I made pink mostly because it looks cool, like it's hot pink, but also what kind of came out afterwards is like, this is a good reason because, on your workbench, everything is green or purple. So why not do pink? So when these pink LEDs came out, I was like, this is awesome. I'm going to make like an underlighting board to make the JTagulator look like, one of those souped up cars that you see driving down the street. I don't know if people still do that. But there's like neon underlighting on the cars. So I was like, I'm going to do that for my JTagulator that I demo with. So then it's like pink underneath. So these LEDs I got from Kingbright. I wanted to have a minimal connection. So I only have a few through-hole parts on the JTagulator that I can connect to. And I have spring-loaded pogo pins on this board that I ended up making that connect to, I think it's ground and my target voltage line, which can vary from 1.8 to 3.3 volts, depending on what you're connecting, or 1.2 to 3.3, depending on the target you're connecting to. So sort of a voltage in range, and then ground. So I found an LED driver and a boost converter. I think it's two things. I don't even remember. I don't know. I think it's a boost converter and an LED driver. I can't remember. Anyway, it boosts the voltage, and you can run pink LEDs, and it looks awesome, so just trust me.
Well, thank you so much, Joe. I wanted to give you this gift.
Oh, this is amazing.
For coming on. It's
thank
the
you.
USB
a USB fan. Cool. Yeah, so thank you, and thanks for actually sitting here and listening.
Yeah, I don't understand why you people are still here. I don't think we have time for questions.
No.
Joe talked too much.
Don't ask questions.
So thank you, guys.
Oh, grandideastudio.com, @JoeGrand on Twitter. Then you can ask me questions. Or here, because I'm still going to be
You
around.
can talk to him in person.
Just look for Will, and I'll be next to Will. Thanks.
Do you want a mic?
Oh, it's nice and warm in here with the fire. We heated it up. Yeah. Okay, cool. Thanks.
Yeah, that's yours. I'm sorry.
Okay. Cool. So we are now talk a little bit about the puzzle hunt. Right after this, we're going to go to Autodesk, which is just across the river. It's about a mile away by foot. You can take the streetcar, kind of the scenic route. There's a streetcar right next to PNCA, I think, and it drops you off right next to Autodesk. Or you can walk maybe a quarter mile down to Burnside and catch almost any bus across the bridge, or you flap your wings or whatever. Yeah, you can just follow me too. Yeah, anyone in a blue shirt will suffice. So the puzzle hunt tonight, it's teams. You get to choose your teams however you want. I don't care. You have to designate a team captain. And that person is most of the person who just gets to hear logistical stuff. If you didn't read the update last night, there's no real prize. It's just glory, right? Which is good. Yeah. It's for fun. The only rules are that you can't sabotage puzzles so that other people can't solve them. You can totally spy on other people or follow them around or whatever. That's great. But just leave the puzzles intact. And in some cases, if it's ambiguous, use your good judgment. If there's just one thing, don't take it. Just take a photograph of it or something and leave it for the next person. The way the puzzle hunt is structured, it's kind of a location-based thing. You're going to get a puzzle. I'll give it to you after dinner at Autodesk. So you huddle with your team, solve that puzzle, hopefully, and the solution will be a location. The solution to every puzzle is a location. And it may not be obvious what that location is, but that's part of your job. So you go to that location and there'll be another puzzle, and then another and another and another, right? So the winning team is the team that gets to the last puzzle first, or the location of the last puzzle first. And we're doing this through all 3 days, but we're gonna shut down each day at a different time, or you can't solve the entire thing in one day. You have to go through all 3 days. But if you just want to do it for one day, that's cool too. It's still fun. Any questions about this? Yeah, sweet. Yeah, so thanks for Autodesk for hosting. It's a pretty cool space if you haven't been there. We had a chance to see it right when it first opened last year. It wasn't even approved by the fire marshal, I think, at that point. But this, I've been in it for a little bit, and it's really nice. And it's a beautiful day outside. It's the solstice today, right? Yeah, I think so. Happy solstice. We have plenty of daylight to do this stuff. I think I'm forgetting to say something, but I'm sure I'll talk to y'all later. Cool. Thanks. Yeah, you can head over anytime starting now.